Hi everyone. I hope everyone is doing perfectly great. So, my dear students, let's start today's important class. And in today's important class, we are going to discuss about carbon and its compounds. This is going to be one short class, and in this class, we'll be discussing all the related concepts that can be asked in your examination and that will be asked in your examination CBSE 2026. So guys, let's begin without any delay and let us start the first part of it, and that's brief introduction about carbon. Let's begin with the brief introduction about carbon. I will write down few lines so that you will get the idea what basically carbon is, right? I'll be starting from the scratch. So guys, the first point that I would like to mention here is carbon 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 is the carbon is the non-metallic element non-metallic element non-metallic element non-metallic element having atomic number having atomic number 6 and mass number 12 right? Atomic number 6 and mass number 12, right? Mass number 12. Clear? That's one point about carbon, that it's a non-metallic element. Carbon is actually non-metal, carbon is actually element, we know that, and it's non-metallic element and its atomic number is 6. Guys, you should know that when I say atomic number is 6, I actually mean how many protons carbon has. Carbon has 6 protons, because when I define atomic number means number of protons only, right? In the same way, it has mass number 12. Let me tell you, mass number here means number of protons plus number of neutrons. And how many protons carbon has? 6 protons. How many neutrons carbon has? It has 12 neutrons. So its mass number will be 12. Now we have few isotopes of carbon, like carbon 13, like carbon 14. And in carbon 13, number of neutrons is 7. In carbon 14, number of neutrons is 8. So 8, 9, 10, 11, 12, 13, 14. Clear? I hope the idea is clear, guys. I hope the idea is clear. So this was the first point. Let's switch on to one more point, guys. Let's switch on to one more point. Clear? If I talk about this carbon is the base element of organic chemistry. It's the base element of organic chemistry. What does it mean? Organic chemistry. It's the base element of organic chemistry, guys. What does it mean? What does it mean, base element of organic chemistry? I will make you clear. For that, we need to understand what is the meaning of organic chemistry. Guys, if I ask you what is the meaning of organic chemistry, you should be able to define organic chemistry as. Organic chemistry, it is actually the branch of chemistry that deals with the study of organic compounds, I hope this is clear. I hope this particular term is clear. Study of organic compounds, right? Study of organic compounds. So when it comes to organic chemistry deals with the study of organic compounds. Now the point is, sir, what are organic compounds? What is the meaning of an organic compound? Yes, for that we need to understand few things. And for that we have one early theory. Clear? We'll be starting from the early theory. That early theory, actually we have vital force theory. The early theory is vital force theory, right? Vital force theory. This theory was actually given by Berzelius, Berzelius, right? This theory was given by Berzelius. As for the vital force theory, in order to prepare an organic compound, you actually need a vital force, right? Or in other words, I can say that in order to create an organic compound, what we actually need? We need the source from plant, or we need the animal source. So that was the main crux of vital force theory. So vital force theory actually focuses more on vital force. It focuses more on vital force, and this vital force actually comes from either plants or animals. It actually comes from either plants or either animals. So in order to have an organic compound, we actually need either plant or animal source. So classically we can define organic compounds as the compounds that are obtained directly or indirectly from plant or animal source. That was one traditional and classical definition. But what happened, this vital force theory, it was disproved later on. Who disproved it, I will let you know in some time, guys, in some time. So Berzelius, actually a Swedish chemist, in 1815 proposed that organic compounds are produced only under the influence of some mysterious forces, guys, right, existing in the living organisms. This mysterious force was called as vital force, that I have already discussed. Now guys, look here, this was actually disproved by Wöhler. He says that you don't need the living sources, you don't need the plant or animal source in order to create an organic compound, right? So he disproved. What he did, guys, he actually took ammonium chloride, NH4Cl, and he reacted ammonium chloride with KCNO, potassium cyanate. Now look here, guys, what will happen? I know that this is NH4 positive and this is Cl negative, this is K positive, this is CNO negative. Now cation, positive is cation, it will go with the anion. So it will form NH4CNO and it will form KCl, right? It will form KCl. Look here, this is an inorganic compound. This is also an inorganic compound. They are not organic compounds. They are inorganic compounds. And when we create this NH4CNO, what he did after that? He again heated this NH4CNO, right? He supplied heat to it. Because of heat, what happened, guys? I will write down. Because of heat, what happened? Rearrangement of atoms took place. Rearrangement of atoms took place. Rearrangement of atoms took place, right? Rearrangement of atoms took place. And because of this rearrangement of atoms, what happened? This NH4CNO, it got converted into NH2CO, NH2, and we call this NH2CO, NH2 as urea, right? And urea, guys, let me tell you, is organic compound. It is an organic compound. So in order to create an organic compound, we don't need plant or animal source. You can check out, guys, ammonium chloride, inorganic source, KCNO, inorganic source, potassium cyanate, inorganic source. And from these two, we actually got what? Urea. We actually got urea. And let me tell you, guys, this urea is an organic compound. Actually, he accidentally manufactured the urea. He was trying to do some other reactions, and then because of those reactions, he actually got urea. And hence, he disproved the vital force theory that states in order to create an organic compound, you need plant or animal source. So he disproved that theory. Right? Let's now move ahead. There is one simple statement. After urea, guys, Cobb prepared acetic acid in 1845 and Beckwith prepared methane in 1856. They prepared them from inorganic sources, so vital force theory was rejected. Now you can define organic compounds in a much better way. Let's try to define organic compounds in a much better way. Right, guys? So what are organic compounds? What are the modern definition of organic compounds? Let me write down. Organic compounds are the compounds Organic compounds are the compounds that contain carbon and hydrogen mainly, right? That contain carbon and hydrogen. And when we have any compound, that compound contains carbon and hydrogen, we call such compounds as hydrocarbons. Right? We call such compounds as hydrocarbons. Hydro means hydrogen, carbon means carbon. So what are organic compounds? These are the compounds that contain carbon and hydrogen. Clear? And we call them as hydrocarbons, right? I hope this simple definition is clear. Now guys, we have few of the exceptions there. For example, if I talk about oxides of carbon, it contains carbon. For example, CO2, it contains carbon. In the same way, we have carbonates, we have bicarbonates, etc. They are still studied under inorganic chemistry, right? They are still studied under inorganic chemistry, although they contain carbon, but still they are studied under inorganic chemistry. The reason for that is that their properties, they match with organic compounds. Their major properties match with inorganic compounds. That's why they are studied. They are studied under inorganic chemistry. What are the exceptions? Carbonates, bicarbonates, oxides of carbon, for example CO and CO2. I hope that this idea is clear. What is the modern definition of organic chemistry? So guys, we're discussing some important points related to carbon. So we have discussed 2 points. Now let us switch on to third important point. If I talk about these organic compounds, third important point, if I talk about these organic compounds, generally they have low melting and boiling point. They generally have low melting and boiling point, right? Now we need to understand what is the reason that they generally have low melting and boiling point. Now this is somewhat conceptual. Try to understand, guys, how I'll be dealing with this concept. See, let's take the example of methane. Guys, you should know what is the formula of methane. It is CH4, right? It is CH4. Clear? If I write down, for example, this is one molecule of methane, CH4. This one molecule of methane will combine with one more molecule of methane, right? It will combine with one more molecule of methane, right? In the same way, it will keep on combining with millions of molecules, and then it will form a methane gas. Then it will form methane gas. Now look here. Can I say that there will be a force of interaction, there will be the force of attraction between this methane molecule and this methane molecule? In the same way, there will be force of attraction between this methane molecule and this methane molecule. Can I say? Yes, definitely I can say. In the same way, if I talk about this CH4, guys, can I say it's connected by hydrogen? It's connected by hydrogen. So can I say that between this carbon and hydrogen there is a bond? In the same way, between these molecules there is a bond. Now look here, guys. These bonds have names. If I talk about these bonds, the bond that lies between two methane molecules, this bond I'll be calling as intermolecular force of attraction. I hope the idea is clear. And this bond that exists between carbon and hydrogen, this bond I'll be calling as intramolecular force of attraction. Guys, intra means between and inter means within. Inter means between and intra means within. So this bond is within the molecule and this bond is between the molecules. Let me make it clear here. This bond is strong. Which bond, guys? This bond that I'll be calling as intramolecular force of attraction. This bond is strong, but when it comes to intermolecular force of attraction, so this bond is not strong. This bond is a weak bond. Now try to understand, guys. If I have to convert, for example, these organic compounds, I have to convert their states. So I have to break these bonds, guys. And in order to break this bond, I need less energy. In order to break this bond. That's why, guys, we say that organic compounds, their boiling point, their melting point is generally low. Because in order to do the convergence, we have to break the bond. And in order to break the bond, we need less energy. Why we need less energy? Because the bond between the two molecules is weak bond. That's why we need less energy. But when it comes to this particular thing, when it comes to the particular molecule, the bond between carbon hydrogen is strong bond. And guys, let me tell you, this bond is covalent bond. Most of the students, they have confusion. Sir, if covalent bond is strong, guys, then why there is low melting and boiling point? The reason for that is intermolecular force of attraction is weak, and we have to break this intermolecular force of attraction in order to change the state. I hope this point is quite clear. This point is clear, quite clear. So why carbon and its compounds have generally low boiling and melting point? Because intermolecular force of attraction is, yes, intermolecular force of attraction is weak. I hope this point is quite clear. Now let us switch on to point number 4th. Let us switch on to point number 4th, and point number 4th is structure of carbon. Point number 4th, guys, is structure of carbon. Right? How exactly I'll be drawing the structure of carbon? For that, we need to understand, if I talk about carbon, guys, what is the atomic number of carbon? Sir, atomic number of carbon is 6. So, how many protons are present in carbon? You can say 6 protons. Since carbon is an element, electrically neutral, so how many electrons are there? Sir, it has 6 electrons. And how many neutrons it has? Sir, it has 6 neutrons. Now, let's try to draw its structure. How exactly I'll be drawing its structure, guys? How exactly I'll be drawing its structure? Now, we'll get the idea. So, if I talk about its electronic configuration first, if I talk about its electronic configuration, so in the first shell you will keep 2 electrons, in the second shell you will keep 4 electrons. Now try to draw its structure. So how many shells are there? 2 shells. This is shell number 1, for example, and this one will be shell number 2, right? This is clear. So these are 2 shells present, right? Now guys, look here, in the first shell, how many electrons are present? You can say that 2 electrons are present. In the second shell, how many electrons are present? You can say, sir, 4 electrons are present. 1, 2, 3, and 4. Right? This shell I'll be calling as K shell, and this shell I'll be calling as L shell. Now, inside the nucleus, this part I'll be calling as nucleus. Inside the nucleus, how many protons will be there? So there will be 6 protons. 1, 2, 3, 4, 5, and 6. And how many neutrons will be there? There will be 6 neutrons. 1, 2, 3, 4, 5, 6. And this part I'll be calling as nucleus. I hope this idea is clear, and that is the structure of carbon. So this is the structure of carbon atom. Done, guys? This is the structure of carbon atom. I hope this particular point is clear. It was the point number 4th, right? It's point number 4th. Now let's switch on to point number 5 about carbon. What is the percentage of carbon in this atmosphere? The percentage of carbon is 0.03%, right? The percentage of carbon is 0.03%, mainly in the form of CO2, and there are few traces of CO as well. That, guys, you need to understand. Clear? Point number 6, if I talk about point number 6, about this carbon, since carbon forms carbon compounds, yes, guys, carbon forms carbon compounds, right? It forms carbon compounds. If I talk about these particular carbon compounds, their application, their utility, so we use these carbon compounds, or we use carbon in making different drugs, we can say, right? In making perfumes, guys, we can say perfumes, and extra in making different things, right? For example, guys, if I talk about aquatic animals, many aquatic animals, they have the shells made up of carbon. They have the shells made up of carbon, right? That's one more application of carbon compounds. Clear? So these points are super duper clear. These points are super duper clear. Now guys, imagine. Let's move ahead and now imagine. Imagine, for example, I have something, right? I have something. This is something I'm having. This is something I'm having. I don't know what is this. Or for example, I will name it as piece of paper, right? This is a piece of paper. Now I need to check, guys. For example, this is the piece of paper. Yes. And I need to check, does this piece of paper contain carbon? So how actually you are going to check it, right? Can you smell it? Sir, it has a carbon smell, right? No, you can't say that, right? So for that, what you have to do? Let me tell you, test for the presence of carbon, right? Okay, guys, test for the presence of carbon. For example, I am taking one container, guys. I am taking one container, right? This is one container, and I am taking one more container. I am taking one more container, right? And I'll be connecting a pipe with this container as well as with this container. I'm connecting a pipe, right? And here it's my mouth, right? It is my mouth. We know that we inhale oxygen, we exhale CO2, we exhale, guys, what we exhale? CO2. Now tell me, this CO2 contains what? This CO2 contains what? Carbon. This CO2 contains what? Carbon. I have to check whether I am inhaling, whether I am exhaling CO2 or not. For that, I am taking two containers. I will be connecting them with the pipe. In this container, I will simply keep water, right? I will simply keep water. And in the second container, guys, I will keep CaOH twice in aqueous form, and this we call as calcium hydroxide, right? Calcium hydroxide, or we call this as lime water. And let me tell you guys, this lime water is colorless, right? It is colorless. I hope the idea is clear. It's colorless, right? So in this container I have kept water. In this container I have kept water. In this container I have kept, yes, calcium hydroxide, or I'll be calling as lime water. Now since you pass CO2, when the CO2 will reach here, nothing will happen, guys. But as soon as the CO2 will reach here, as soon as the CO2 will reach here, what will happen? Reaction will happen. Sir, what reaction will happen? Which reaction will happen? Let me tell you, this CaOH twice, it will react with CO2 and it will lead to the formation of CaCO3. It will lead to the formation of CaCO3 plus H2O. Now, if I talk about this CaCO3, this CO3 is calcium carbonate. It's calcium carbonate. And what is its color? It is milky or turbid in color. Milky, or you can write down turbid is its color, right? I hope this idea is clear. So whenever there occurs a change from colorless to milky color, we can say that there is carbon. Now imagine, guys, I need to check whether this paper contains, whether this piece of paper contains carbon or not. Then I have to burn it first, and again I have to pass that CO2 through this lime water, right? Through this lime water. If it will change its color to milky, then we can confirm that yes, it contains carbon. I hope this is clear. Now we can write down, we can conclude one simple statement in order to test the presence of carbon. So carbon and its compounds, burn in air to produce CO2, which turn lime water milky. I hope this particular point is clear. So carbon and its compounds, they burn in air to produce CO2, and this CO2 turns lime water milky. And few minutes back I have shown you the reaction. So that's one simple test for the presence of carbon. Now guys, let's move ahead. Let's directly discuss the features of carbon, right? Let's directly discuss the features of carbon. We know that carbon is versatile in nature, and the first point about carbon is that carbon forms covalent bond. Now guys, what is a covalent bond? That we need to understand, which is one important point. What is a covalent bond, right? Let's move ahead. Let us discuss the concept of covalent bond in detail. Clear? Let me write down the definition of covalent bond first. The bond formed by the mutual sharing of electrons. The bond formed by the mutual sharing of electrons. The bond formed by the mutual sharing of electrons is called as a covalent bond. Covalent bond. Sir, what does it mean? You are not getting it. Let's try to understand this with the help of one simple example. Imagine guys, you are two friends, okay? The name of friend A, for example, there are two friends, friend A, and there is one more friend, friend B, right? Friend A want to get the chocolate, as well as friend B want to get a chocolate. But let me tell you, friend A has only 5 dirhams, right? Friend B has only 5 dirhams. Now both wanted to get the chocolate. Clear? Now this friend A went to the shopkeeper. Bhaiya, this is the shopkeeper. Bhaiya. Shopkeeper bhaiya, give me the chocolate. I want the chocolate. I have 5 dirhams. But shopkeeper bhaiya is saying that I don't sell the chocolates of 5 dirhams. If you want to have the chocolate, so I have the chocolate of 10 dirhams. So A came back. Now B is saying that I will get the chocolate definitely. He went again to the shopkeeper bhaiya saying that I have 5 dirhams. Can I get the chocolate? Again. Shopkeeper bhaiya says no. So he went back, right? Now, guys, what happened? What happened, guys? Look here. A and B, they mutually decided something. So they mutually decided, can't we do one thing? Oh, can't we do one thing? Right? Can't we do one thing? Let me share my 5 dirhams with you. Let me share my 5 dirhams with you, right? Let me share my 5 dirhams with you. Let you share your 5 dirhams with me. So 5 plus 5 will give us 10 dirhams. We will get the chocolate of 10 dirhams. We'll get the chocolate in 2 equal parts. That's it. That's the solution. Yes, guys. That is the solution. Let me tell you, in our life, everything has a solution. Every point, every problem, everything has a solution. When this universe was created, before creation of the universe, we know that before the creation of the universe, guys, there was chance that problems might happen. So before that, the solution of the problems was basically created by the God, right? So wherever there is problem, there is the solution. I know in your life there are certain problems that you are facing right now. Be it related to your exam, be it related to your family, be it related to your personal life. There are few of the problems that you are facing right now. But yes, every particular problem has a solution. You just need to think on it, right? You just need to utilize some time on your problem in order to solve that problem, because every problem has a solution, like this way. Clear? Now look here guys, they're sharing in the same way. In chemistry, we are sharing the electrons, right? Elements are sharing the electrons, and that sharing of electrons is what we call as covalent bond. It's called as covalent bond. How exactly? I'll make you understand. Look here, guys. Let's again talk about CH4 methane, right? Let's again talk about CH4, which is methane, right? If I talk about carbon, how many electrons carbon has in the last shell, guys? You know the electronic configuration of carbon is 2, 4. So in the last shell, how many electrons are present with the carbon? You can say, sir, 4 electrons. 1, 2, 3, and 4 electrons, right? Since there are 4 hydrogens as well, let us say this is hydrogen number 1. Let us say this is hydrogen number 2. This is hydrogen number 3, and this one is hydrogen number 4. And how many electrons are present with the hydrogen? We know that one electron is present with the hydrogen. One electron is present with the hydrogen. In order to gain stability, guys, hydrogen needs how many electrons? 2 electrons, right? So how actually hydrogen will get the 2 electrons? So this particular hydrogen will share its electron with the carbon, and in return will get electron from the carbon. This way this hydrogen is stable. In the same way, this hydrogen will share 1 electron with the carbon, and in return will get 1 electron from the carbon. This way stable. This way this hydrogen is stable. This way this hydrogen is stable. So hydrogen needs 2 electrons in the last shell to gain stability. Hydrogen is stable. Now guys, what about carbon? Is carbon stable? Yes or no? Is carbon stable, guys? Yes or no? Look here, is carbon stable? Since carbon shared 1 electron, got 1 electron. Shared 1 electron, got 1 electron. Shared 1 electron, got 1 electron. So 2, 4, 6, and 8. So this way our carbon is stable as well, having 8 electrons in the last cell, because carbon needs 8 electrons in the last cell. Hydrogen is 1, so it needs only 1 electron, right? But carbon, it has 2, 4, so it needs 4 electrons in the last shell. So that its valence will become 2, so that its electronic configuration will become 2, 8. I hope this thing is clear. And this type of bond that is formed here, look here, guys, this type of bond, that's called as covalent bond, right? This bond, and it's represented. Since here, how many electrons are being shared? There are 2 electrons, or we can say that 1 pair of electron is being shared, right? 1 pair of electron is being shared. How many pair of electrons are being shared? You can say, sir, 1 pair of electron is being shared. 1 pair of electron is being shared. 1 pair of electron is being shared. So we represent that 1 pair of electron with a single line. So can I say that carbon, single bond hydrogen, single bond hydrogen, single bond hydrogen, single bond hydrogen? I hope this idea is quite clear, right? Shall I move ahead, guys? Yes. Now there is one common question: does carbon atom shares all of its 4 electrons with another carbon atom to become stable? For example, guys, if I talk about carbon, look here. This is carbon, and there is one more carbon. How many electrons are present with the carbon? How many electrons are present with the carbon? You can say, sir, 4. 1, 2, 3, and 4. With this carbon, 1, 2, 3, and 4. Right? Can I say that this carbon will share all the 4 electrons with this and become stable? This carbon will share all the 4 electrons with this and become stable, and they will form a quadruple bond. This bond is called as quadruple bond. Quadruple bond. The answer is big no. This thing can't happen. Right, guys? This thing can't happen. Carbon can't form quadruple bond. So the answer of this question is no. Right? Now, types of covalent bonds. Let me make you understand. We have generally 3 types of covalent bonds: single covalent bond, double covalent bond, and triple covalent bond. So I'll be starting with single covalent bond. Single covalent bond. Single covalent bond. And directly I'll make you understand with the help of example. Single covalent bond. Guys, for example, I'm talking about hydrogen, right? Hydrogen. Hydrogen, in order to gain stability, needs how many electrons? Since this hydrogen has only 1 electron, so in order to gain stability, this hydrogen needs 1 more electron, and this is 1 more hydrogen. This hydrogen has 1 electron with it. So if they will share these electrons with each other, can I say they will gain stability? This way the hydrogen can gain stability. This way the hydrogen can gain stability. Now can you answer one simple question? How many pair of electrons they are sharing? You will say, sir, they are sharing 1 pair of electron. 1 pair of electron. 1 pair of electron. That is represented by a single line. So I can say that hydrogen single bond hydrogen. So whenever there is sharing of 1 pair of electron, that bond we call as single covalent bond. So what is single covalent bond? It is a type of covalent bond. It is the type of covalent bond that's formed. Is the type of covalent bond that's formed by mutual sharing of 1 pair of electrons. Right? And here you should know that 1 pair of electrons means 2 electrons, right? It means 2 electrons. I hope this idea is super clear. So we have single covalent bond. In the same way, guys, we have double covalent bond. Double covalent bond. Now what's double covalent bond? For that, let's take the example of oxygen, right? This is oxygen. The atomic number of oxygen, guys, we know that it's 8, so its electronic configuration will be 2, 6. So how many electrons will be present in the last cell of oxygen? It will be 6. 1, 2, 3, 4, 5, and 6. If there will be one more oxygen, how many electrons will be present with that oxygen? 1, 2, 3, 4, 5, 6. Now oxygen, in order to gain stability, guys, can I say that they need 1, 2, 3, 4, 5, 6 are there, so they need 2. So what will happen? This oxygen will share its 2 electrons with this oxygen. In return, we'll get 2 from this oxygen. So can I say that this way oxygen is stable? 4, 5, 6, 7, 8. Can I say this way this oxygen is stable? Right? Yes, 4, 5, 6, 8. Now this time, how many pair of electrons they are sharing? Can I say they are sharing 1 and 2 pair of electrons? So I can say they are sharing 2 pair of electrons. 2 pair of electrons. 2 pair of electrons means how many electrons? 4 electrons. 4 electrons, and that's represented by a double line. So I can say oxygen double bond oxygen, because single line represents 1 pair, one more line will represent 1 more pair. So there is sharing of 2 pair of electrons. So what is double covalent bond? Double covalent bond is that type of covalent bond which is formed by mutual sharing of 2 pair of electrons. 2 pair of electrons, right? 2 pair of electrons, and it is represented by a double line. I hope this thing is clear, guys. Yes. In the same way, we have triple covalent bond. Yes, we have triple covalent bond. Triple. Triple covalent bond. Triple covalent bond. Yes. Let's try to understand this concept with the help of one simple example, and that example is nitrogen, guys. Right? How many electrons are present in the last cell of nitrogen? Since the atomic number of nitrogen is 7, its electronic configuration will be 2, 5. So there will be 5 electrons present in the last cell of nitrogen. 1, 2, 3, 4 and 5. If there will be one more nitrogen, imagine it will be having 1, 2, 3, 4, 5 in the last shell. Now look here guys, quite simple. Look here, this nitrogen needs how many electrons to gain stability? As it already contains 5, so it needs 3, 5, 6, 7 and 8. 5 plus 3 is 8. So it will get those 3 electrons from this nitrogen, and in return it will share its 3 electrons with the nitrogen, right? So the thing is quite clear guys. The thing is quite clear. This nitrogen is stable, and let me tell you, this nitrogen is also stable, right? This nitrogen is stable and this nitrogen is also stable. Now how many pair of electrons they are sharing? 1, 2 and 3. There is sharing of 3 pair of electrons, that is represented by 3 lines. One line represent 1 pair, 2 pair, 3 pair. So there is mutual sharing of 3 pair of electrons, or we can say 6 electrons. So triple covalent bond is that type of covalent bond in which there is mutual sharing of 3 pair of electrons, right? 3 pair of electrons. I hope this is clear, right? Three pair of electrons. Clear? Now, let's move ahead. Let's try to draw the structure of these molecules, these compounds. For example, we have dihydrogen monoxide. What is dihydrogen monoxide? H2O, right? How many hydrogens are present there? Can I say 2 hydrogens and 1 oxygen? This is 1 oxygen, this is 1 hydrogen, this is 1 hydrogen. Now guys, just mention the electrons. How many electrons are present with the hydrogen? Can I say 1 electron? How many hydrogen electrons are present with the hydrogen? Can I say 1? And how many electrons are present with the oxygen? Can I say 6 electrons? So this is 1, 2, 3, 4, 5 and 6, right? These 6 are of oxygen, right? Hydrogen, in order to gain stability, this hydrogen needs 1 electron, it will get that electron from oxygen, right? This hydrogen needs 1 electron, it will get from the oxygen. But remember guys, in return, this hydrogen is sharing electron with the oxygen. Now check out how many electrons are with the oxygen. 1, 2, 3, 4, 5, 6, 7, 8. Is oxygen stable? Yes. Is oxygen stable guys? Yes, oxygen is stable. Now tell me, in short, how many pair of electrons they are sharing? Can I say that this hydrogen is sharing 1 pair of electron with the oxygen, and this oxygen is sharing 1 pair of electron with the hydrogen, this way, right? So how many pair of electrons they are sharing? 1 pair and 1 pair. So they are sharing 2 pair of electrons. So shared pair of electrons. How many shared pair of electrons are there guys? There are 2 shared pair of electrons, or we can say there are 4 total electrons that are being shared. Now, lone pair of electron. Lone pair of electron is that electron. Remember guys, lone pair of electron is that pair of electron basically that does not take part in bonding, or that does not take part in sharing, right? Look here, how many electrons do not take part in sharing? 1, 2, 3 and 4. 4 electron means 2 pair. So the answer will be quite simple too. Now type and number of bonds. How many bonds are there? 1 and 2 bonds. And both bonds are what? Single bonds. So can I say that? 2 single covalent bonds, right? 2 single covalent bonds. I hope this idea is clear, right? Now, let's try to draw the structure of CO2, carbon dioxide. So there is carbon, there is 1 oxygen from this side, there is 1 oxygen from this side guys. Again quite simple. Carbon has 4 electrons. Can I say this is 1 electron, 2, 3 and 4. Oxygen has how many electrons in its shell? Can I simply say that oxygen has 6? So 1, 2, 3, 4, 5 and 6. This oxygen has 6. 1, 2, 3, 4, 5 and 6. Now guys, quite simple. Oxygen, in order to gain stability, will get 2 electrons from this carbon. 2, 4, 6 and 8, stable. This oxygen will get 2 electrons from this carbon, stable. Since carbon is sharing 2 electrons from here, 2 electrons from here, in return carbon is also stable. Carbon is also stable. Now what I can conclude from here? Can I say that oxygen is making double bond with carbon, and this carbon is making double bond with oxygen? Now guys, if I ask you one simple question, can you just let me know shared pair of electrons, how many pair of electrons they are sharing? So from this side 2 pair of electrons it's sharing, from this side 2 pair of electrons it's sharing. So shared pair of electrons will be 4, right? Shared pair of electrons will be 4. 1, 2, 3 and 4, 8 electrons, right? A lone pair of electrons, those electrons that do not take part in bonding. How many? 1 pair, 2 pair, 3 pair and 4. Answer will be 4 pair of electrons that do not take part in bonding. Type and number of covalent bonds. Can I say that? 2 double covalent bonds, right? 2 double covalent bonds. 1 bond, right? But both bonds are double. So 2 double covalent bonds. I hope this thing is also clear. Yes. Let's move to one more example. Draw the structure of nitrogen trihydride, right? Nitrogen trihydride. Nitrogen trihydride means NH3. So I can say this is nitrogen, this is one hydrogen, this is one hydrogen, this is one hydrogen, right? Quite simple, guys. So hydrogen has one, hydrogen has one, hydrogen has one. Nitrogen has how many? 5. So try to make the 5. 1, 2, 3, 4 and 5. Quite simple. Hydrogen, guys, stable. Hydrogen, guys, stable. Hydrogen, guys, stable. In return, is nitrogen stable? 2, 4, 6 and 8. Yes, nitrogen is also stable. I hope this idea is clear. Yes. Now can you let me know how many shared pair electrons are there? Yes. How many shared pair electrons are there? You can let me know. Yes. So one pair, two pair and three pair of electrons are being shared. How many lone pair electrons are there, guys? How many lone pair electrons? Just let me know. Let me know in the comments, right? Let me know in the comments, right? And type and number of covalent bonds. Can I say that 3 single covalent bonds, right? 3 single covalent bonds, right? 3 single covalent bonds. I hope this thing is clear. Now, sometimes some students they ask, sir, how we will make the structure of CO, right? Carbon monoxide, right? Well, let me tell you, this is in your next grades, but I will just make it clear for you people. If I talk about this carbon, how many electrons are present in this carbon? Can I say 1, 2, 3 and 4? In this oxygen, can I say 1, 2, 3, 4, 5 and 6, right? Let's write down carbon here. Let's write down oxygen here. Look here, guys. Carbon and oxygen, I will make a single bond, right? Single bond means, look here, guys, very simple. Single bond means this electron, right? After that, guys, one more bond will be there. One more bond will be, yes, one more bond will be between, for example, this and not this, between this and between this, right? This one will be there, right? Between this and this. Clear? Now try to understand. If this is carbon, if this is oxygen, right? So carbon has 1, 2, 3 and 4. Oxygen has 1, 2, 3, 4. Clear? And 5, 6. So this carbon is sharing this electron with it. This carbon is sharing with this electron. Now tell me, guys, how many electrons are with the oxygen, right? 1, 2, 3, 4, 5, 6, 7, 8. Stable. But is carbon stable? 1, 2, 3, 4, 5, 6. No, carbon is not stable. Now carbon, in order to gain stability, let me tell you, this oxygen will completely share one pair of electron with the carbon, right? It will completely share one pair of electron with the carbon, right? It will completely share one pair of electron with the carbon, right? And we call this bond as coordinate covalent bond. We call this bond as coordinate covalent. What's happening? Coordinate covalent bond. We call this type of bond as coordinate covalent bond, right? Now tell me, guys, is it stable? Since now these two electrons are being shared completely here, tell me 2, 4, 6, 8. Carbon is stable, guys. Tell me oxygen 2, 4, 6 and 8. Oxygen is also stable. So that way we can say that. Right, guys? That way we can say that it's stable, right? This is stable. I hope the idea is clear, right? Sometimes some of the students they ask this type of question. So there is a bond that's called as coordinate covalent bond, right? Clear? Let's move ahead. Okay, let's move ahead, guys. Now there is one common question. Discuss the structure of sulfur. Let me tell you, normally when we draw the structure of sulfur, we know that sulfur exists in the form of S8, right? So we have to make the 8 atoms of sulfur. 1, 2, 3, 4, 5, right? It will be 6, it will be 7, it will be 8, right? Quite simple. For that we need to understand what is the atomic number of sulfur. It's 16. What will be its electronic configuration? 2, 8, 6. So how many electrons sulfur need, guys? How many electrons sulfur need? It needs 2 electrons. And let me tell you, if I particularly talk about this sulfur, how many electrons are present with this sulfur? So you can say, sir, 1, 2, 3, 4. Wait one second. This is sulfur, right? So 1, 2, you can say, sir, 3, 4, 5 and 6. this way. This sulfur also 6. You can say, sir, 1 2 3 4 5 6. This sulfur also 6. You can say 1 2 3 4 5 6. This sulfur also 6. You can say 1 2 3 4 5 6. This sulfur also 6. So you can say 1 2 3 4 5 6. Similarly, this sulfur 1 2 3 4 5 6. 1 2 1 2 3 4 5 6. 1 2 3 4 5 6. Right? Now look here, guys. How this sulfur will gain stability? Quite simple. Same, this sulfur is 1 2 3 4 5 6, right? It will share this electron with this sulfur. In return, we'll get electron from this sulfur. And from this side, again it will share its electron with this sulfur. In return, we'll get this sulfur. Now look here. Is this sulfur stable? 1 2 3 4 5 6 7 8, right? That's stable. So sulfur actually makes single bond from this side, single bond from this side. Now in the same way, the sulfur is doing same thing. It will share one electron downwards, one electron upwards, right? In this way, this sulfur is also stable. 1 2 3 4, 1 2 3 4 5 6 7 8, right? Again, the sulfur single bond, it will keep on going, right? This type of structure. So 1 2 3 4 5. 1 2 3 4 5 6 7 and 8, right? 1 2 3 4 5 6 7 and 8, right? This way sulfur is making a structure. But let me tell you, sulfur actually has king's crown structure. Sulfur actually has king's crown structure. Sulfur actually has king's crown structure. How exactly king's crown structure look like? Just make a W this way, right, guys? Make one more W this way, and at every point or at every vertices, just mention the sulfur. This is 1 sulfur, 2 sulfur, 3 sulfur, 4 sulfur, 5 sulfur, 6 sulfur, 7 sulfur, 8 sulfur. And this particular structure is called as king's crown structure. I hope this thing is clear. Yes, I hope this particular thing is clear, guys. So sulfur actually has king's crown structure. Now guys, what are covalent compounds? What are covalent compounds? Quite easy. Covalent compounds are the compounds that contain covalent bond. That contain covalent bond. That contain covalent bond. They are called as covalent compounds. For example, CH4, it's a covalent compound. Methane, few minutes back I told you. Wherever there is mutual sharing of electrons. For example, guys, H2O, it's a covalent compound, right? It's a covalent compound. Clear? Right? For example, if I talk about CO2, again, it's a covalent compound. Why it's a covalent compound? Because there is mutual sharing of electrons, right? Now, what are the different properties of covalent compounds? What are the different properties of covalent compounds? The first point is covalent compounds are made from. How they are made from? And we know that they are made from mutual sharing of electrons. Yes, mutual sharing of electrons. Mutual sharing of electrons. Done? Point number 1 is clear? Yes. Point number 2 is physical state. What can be the physical state of covalent compounds? Guys, let me tell you, they can be solids. One example is, for example, dry ice, right? Dry ice. What is dry ice? It is CO2 in the solid form. Clear? They can be liquids, right? Clear, guys? They can be liquids. At the same time, for example, H2O we can say, right? Clear? And they can be in the gaseous form, right? For example, CO2 in the gaseous form, right? So their physical state can be solid, they can be solids, they can be liquids, they can be gases. What is their electrical conductivity? Let me tell you, they are generally bad conductors of electricity, right? They are generally bad conductors of electricity. They are generally bad conductors of electricity. Point number next, solubility. What about their solubility? So they are generally insoluble in water, but soluble in organic liquids, because Like dissolves like. Like dissolves like. Try to understand, guys, what does it mean? Because like dissolves like. What does it mean? Try to understand. Imagine this is one container I have, right? In this container I have kept H2O. What is H2O, guys? H2O is water. And let me tell you, water has partial polarity, right? So water we treat as a polar molecule, right? Polar molecule means it has charge, it has partial charge, right? So it's a polar molecule. We can say water is a polar molecule, right? And if I put NaCl in it, guys, does NaCl contain charge? Yes, because NaCl is an ionic compound. It dissociates as Na positive, Cl negative. Now tell me, can you dissolve NaCl in water? Is NaCl soluble in water? You can say yes, NaCl is soluble in water. Why? Because like dissolves like. It's also a polar molecule. NaCl is also a polar molecule. Water also contains charges. NaCl also contains charge. So like dissolves like. Clear? In the same way, if I talk about these covalent compounds, they are non-polar. Guys. Yes, they are non-polar. Clear? They are non-polar, and they can be dissolved in those liquids that are non-polar. And we know that organic liquids are non-polar liquids. These are the liquids that does not have any charge. For example, kerosene, right? For example, kerosene. Clear, guys? So we can say that covalent compounds, they are generally insoluble in water, but soluble in organic liquids. They can be soluble in organic liquids. For example, kerosene is there, petrol is there. They are organic liquids, for example, right? I hope the idea is clear. Now there are few exceptions. Let me talk about few exceptions. For example, sugar. Sugar is a covalent compound, right? Sugar is a covalent compound, but sugar can be dissolved in water, right? Right? That's one example. In the same way, alcohol, for example, alcohol can be dissolved in water. Let me tell you, alcohol contains OH group, right? OH negative group, due to which it has little charge. Clear? That's why it can be dissolved in water. Which group? Alcohol. Which class of compounds? Alcohol. For example, ethanol. I hope this thing is also clear. Let's now switch on to one more point. What about melting and boiling point? What about melting and boiling point of covalent compounds? I told you their melting and boiling point is generally low, right? That I explained. And last point is they contain covalent bond. The bond that's formed by the mutual sharing of electrons. Let's now move ahead, guys, and let's now discuss ionic versus covalent compounds. Guys, ionic compounds are those compounds that contain ionic bond. For example, if I talk about NaCl, if I talk about sodium chloride. Guys, we know that if I particularly talk about sodium, what is the atomic number of sodium? You should know it's 11. What is the atomic number of chlorine? You should know it's 17. Now tell me how many protons are present with sodium? You can say 11. How many electrons are present? You can say 11. What's the net charge? You can say 0. It's plus 11, it's minus 11. So net charge will be 0. What's the electronic configuration of sodium? You can say, sir, it's 2, 8 and 1. In order to gain stability, can I clearly say that sodium will lose 1 electron? Yes, sodium will lose 1 electron. When sodium will lose 1 electron, how many protons are left, guys? The number of protons will be same, plus 11. And how many electrons are left now? It's losing 1 electron, so it will be minus 10. So what will be the net charge? Net charge will be plus 1. So it will form Na plus, right? Where this 1 electron go? Let me tell you. If I talk about this chlorine, how many protons are there? You will say 17. How many electrons are there? You will say 17. Plus 17 minus 17, net charge is 0. Now, electronic configuration is 2, 8 and 7. So this chlorine needs 1 electron to gain stability. So since sodium is losing the electron and chlorine is gaining that electron. Now tell me how many protons, guys? Proton number you can't change. It's 17. How many electrons? Now 18. Tell me it's plus 17. It's minus 18. So net charge will be minus 1. So can I say that this chlorine has minus 1 charge? Now look here. This plus charge, this minus charge. There's a force of attraction between this plus and minus charge. Because of that, we have the formation of ionic compounds. Covalent compounds I already explained. Right? Now guys, look here. Ionic compounds versus covalent compounds. Yes. So method of formation of bond. So we know that in ionic compounds there is the sharing, there is, wait one second, like in this way. What happened here? There is complete transfer of electrons. Sodium is completely losing one electron. Chlorine is completely gaining one electron. So I can say the method of formation is transfer of electrons. Complete transfer of electrons. Complete transfer of electrons. And what about in case of covalent compounds? There is mutual sharing of electrons. There is mutual sharing of electrons. Right, guys? Okay. Nature of constituent particles. Ionic compounds, they are made up of ions, right? Covalent compounds, they are made up of molecules. This is one more point. They are made up of molecules. Melting and boiling point. Ionic compounds, they generally have high melting and boiling point. In comparison to covalent compounds, they generally have low melting and boiling point. Clear? Electricity conducting nature. Ionic compounds, they are good conductors of electricity, and covalent compounds, they are poor conductors of electricity. What about solubility? Ionic compounds, they are soluble in water. They are soluble in water. And if I talk about covalent compounds, they are soluble in organic solvents. They are soluble in organic solvents. For example, kerosene, etc. I hope this idea is clear. Yes, guys? I hope this idea is clear. Now, second point is tetravalency. Clear? That thing is already clear. Tetravalency means carbon is making how many bonds? If I talk about CH4, for example, if I talk about carbon in general now, this carbon is making 4 bonds. 1, 2, 3 and 4 bonds. Now, this property is called as tetravalency. Right? This property is called as tetravalency. So, carbon is making 4 bonds. Right? And this particular property is what we call as tetravalency. Tetra means 4 and valency, you know, right? Carbon has a valency of 4, so it's making how many bonds? 4 bonds by mutual sharing of electrons. After that, one more property is catenation or self combination, or we call it as self linking property. What does it mean? Catenation, self combination or self linking property. Let me define it. The ability of, or the property of, or ability you can write down, the ability of direct bonding between atoms of the same element, to form long chains, branch or ring structures, is called as catenation. Right, guys? Is called as catenation. So the ability of direct bonding between atoms of the same element to form long chains, branch or ring structures. What does it mean? Try to understand. See, guys, if you talk about carbon can form straight chains this way. It can combine with millions of carbon atoms in this way. Straight chain. Basically, when it comes to defining straight chain is that chain in which carbon is connected, either with one carbon atom or 2 carbon atoms. That forms a straight chain. See, this is a straight chain. So carbon is connected with one carbon, this carbon is connected with 2, this carbon 2, this carbon 2, 2, 2, last carbon is connected with one carbon atom. That's called as straight chain. Either carbon can combine in this way, carbon, it makes a branching type of structure. And branching type of structure we define as when carbon is connected with 1, 2, right? When carbon is connected with 1, 2 or more than 2 carbon atoms. For example, this carbon is connected with 1, this carbon is connected with 2, and look here, this carbon is connected with 1, 2 and 3. right? And this particular type of structure is what we call as, yes, this particular type of structure is what I'll be calling as branch structure. And third one is when carbon atoms they combine in the form of ring. For example, this is one carbon, this is one carbon, this is one carbon, so they are combining in this ring form, right? In this ring form, so they will make the ring structure. And this property of carbon, wherein carbon can link with millions of carbon atoms to form a straight chain, wherein carbon can link with many carbon atoms to form a branched chain, wherein carbon can link with many carbon atoms to form a ring type of structure, that property we will be calling as catenation. Let me tell you, carbon shows the property of catenation, right? It shows the property of catenation due to its small size. Carbon has small size. Due to its small size, it shows the property of catenation. Let's try to find out few more things. Occurrence of carbon. Guys, we know that carbon it can exist in elemental state. At the same time, it can exist in combined state, right? It can exist in combined state. How actually combined state? For example, CH4, methane. For example, CO2, guys, combined state, right? So here carbon is present with hydrogen. Here carbon is present with oxygen. So carbon can be present in combined state, or carbon can be present in elemental state as well. For example, if I talk about carbon, carbon can be present in the form of graphite, right? That's the elemental state of carbon. It can be present in the form of diamond. That's an elemental state of carbon. Wherein, what do you mean by elemental state? Wherein you will only find carbon atoms, nothing else. You will only find carbon atoms, nothing else. In graphite, only carbon is present, nothing else is present. In diamond, only carbon is present, nothing else is present. In the same way, in combined state, you can have carbon connected with other elements as well. Let's move ahead and let's now discuss the case of allotropes of carbon. Guys, I hope you are enjoying the session, since this is going to be one short marathon and it's specifically designed for you people, right? I hope you will enjoy this session. Now, what do you mean by allotropes of carbon, or what do you mean by allotropy, right? Clear? So when an element exist in different physical forms, when an element exists in different physical forms, this particular property we call as allotropy. And the different physical forms are called as allotropic forms, right? And the different physical forms are called as allotropic forms. For example, guys, apart from carbon, if I talk about oxygen can exist in the form of O2, oxygen can exist in the form of O3, oxygen can exist in the form of O4, oxygen can exist in the form of O8, right? Sulfur can exist in the form of alpha sulfur, beta sulfur, right? Rhombic sulfur. Yes, we also called as one more called as monoclinic sulfur. Yes, one more is gamma sulfur, for example, right? So basically, sulfur can have different allotropic forms as well, like oxygen has different allotropic forms. In the same way, carbon can exist in different allotropic forms. And what are the major allotropic forms of carbon, guys? We know that it has three major allotropic forms. One I'll be calling as diamond, and second one I'll be calling as graphite, and third one guys, I'll be calling as fluorines, F-U-L-L-E-R-E-N-E-S. And in our syllabus we have to discuss C60, one particular type of fluorine, right? Fluorines are many in number, but here we have to discuss C60 in detail in our course. Now let's directly start with diamond, right? Let us directly start with diamond, guys. What is diamond? First of all, I will define it. Yes. So let me write down the definition as diamond is a colorless transparent substance transparent substance transparent substance having extraordinary brilliance, right? Brilliance means chamak. Clear? And let me tell you, the symbol of diamond again is C because it only contains carbon. Clear? Guys, if you burn diamond, in presence of oxygen, you will get CO2 only, right? This way. Clear? So basically, diamond is a colorless, transparent substance which has extraordinary brilliance, right? And let me tell you, diamond is very hard, right? It's very hard. Sometimes we say that it is the hardest known substance. What's the melting point of diamond? Just remember the data, 3550 degrees Celsius. And what's the boiling point of diamond? It's 4830 degrees Celsius. So this is how actually you will be defining diamond. Clear? Now guys, how diamond looks like? What is the structure of diamond? This is one important topic. Let me write down one statement. Each carbon atom in diamond is linked to four other carbon atoms, making a three-dimensional tetrahedral structure. What does it mean, guys? Let's try to find out. Each atom in carbon, this is, for example, each atom in diamond. For example, this is one atom in diamond. It is linked with how many atoms? 4 atoms. This way, 1, 2, 3, and 4. Right? Each atom is linked with 4. 1, 2, 3, 4. This, for example, 1, 2, 3, 4. So it's making this type of structure, this tetrahedral type of structure, and we say that this is the structure of diamond. Now, if I ask you one simple question, is there any free atom? Or is there any free electron? No, there is no free electron. As a result, this diamond, it does not help in conduction of electricity. Right? It does not help in conduction of electricity, or we can simply say that that's why it's a bad conductor of electricity, right? Because there is no free electron. You can check that all the atoms are busy in bonding, right? All the electrons are busy in bonding. But at the same time, if we talk about this diamond, these atoms, they actually vibrate. When you supply some amount of heat to the diamond, the diamond atoms, they start vibrating, and because of those vibrations, heat gets transferred from one point to another point. So in diamond, the atoms of diamond, they show vibrations, and because of those vibrations, heat can be transferred from one point to another point, and that particular process will be calling as phononic heat transfer. So let me tell you guys, diamond is the good conductor of heat, right? Diamond is the good conductor of heat. At the same time, diamond is the bad conductor of electricity, right? But it's a good conductor of heat, and that process I'll be calling as phononic heat transfer. So I can say that diamond shows thermal conductivity. Thermal conductivity means conduction of heat, right? Let's move ahead. Let's try to find out few more things. What are the uses of diamond, guys? We know that jewelry purposes. And let me tell you, it's used by eye surgeons, right? Eye surgeons. They actually have the knife. Eye surgeons actually have a knife type device, right? Or we can say knife type instrument. And that knife type instrument has a layer of diamond on it because diamond is very sharp. So it's used by eye surgeons to remove cataract. Cataract is one disorder. Cataract is one disorder in eyes, right? So that's a layer on eyes basically. So they remove that layer of eyes with that knife, and that particular instrument, that particular knife has a layer of diamond on it. So these are few of the uses of diamond. Clear? Now guys, let's move on. Now second one we have graphite. Second one we have graphite, right? Let's try to find out what's graphite. Graphite is a grayish black opaque substance, right? Grayish black opaque substance which is slippery to touch, which is slippery to touch, which is slippery to touch. Clear? And about this graphite, let me tell you, it's derived from the Greek word graphene, G-R-A-P-H-E-I-N, which means to write, right? Guys, you might have seen the pencils, and those pencils, they contain graphite. Even some of the people call that graphite as lead. You might have heard it, people saying it lead, right? Because initially we used to call graphite as plumbago, right? Plumbago means lead, and there is still the endurance of the name, right? But it's actually graphite. So graphite is derived from the Greek word graphene, which means to write, right? And the melting point is 3650 degrees Celsius, and boiling point is more than 4000 degrees Celsius. So very high melting point, very high boiling point at the same time. Clear? Now guys, let's try to find out the structure of graphite. Let's try to find out the structure of graphite. Structure of graphite, right? Structure of graphite. Structure of graphite, right? Let me write down one statement. Each carbon atom in graphite, each carbon atom in graphite, each carbon atom is in graphite is connected with three carbon atoms, right? Is connected with three carbon atoms, making hexagonal ring type structure. Hexagonal ring type 2D structure. Initially graphite has 3D structure, it has 2D structure, right? Graphite has tetrahedral structure, there are hexagonal rings. How exactly? I told you each atom in graphite. Let's, for example, this is one atom in graphite, it's connected with 3 only, 1, 2 and 3, and let me tell you, 1 remains free and its electrons also remain free, right? And here this is connected with 4, this is connected with 4 in this way, right? Everyone is connected with 4, making this type of structure. This will make this type of structure, guys, this type of structure, right? This type of structure, right? In the same way, there will be one more same type of structure here, right? Right guys, same type of structure, right? This type of structure. So these are hexagonal rings. You can check out, these make the hexagonal rings. Clear? And let me tell you, one hexagonal ring is connected with another hexagonal ring, and between them there is a weak force of attraction. There is a weak force of attraction. Weak force of attraction. And let me tell you, this weak force of attraction is what we call as weak van der Waals forces, or weak van der Waals force of attraction. Weak van der Waals force of attraction. This force is very weak. That's why when you write with the help of graphite or with the help of pencil that contains graphite, the layers get easily washed away. While writing, the layers get easily washed away because between the layers there is weak van der Waals force of attraction. You can check out between these layers there is weak van der Waals force of attraction. Now guys, you can check out, only it makes bond with 3 atoms and 1 is free, its electrons will be free. Now, will it help in the conduction of electricity? Yes, it will help in the conduction of electricity. So, can I call it as good conductor of electricity? Good conductor of electricity. I hope this idea is clear. I hope this idea is clear as well. Right, guys, let's move ahead. Let's now write down uses of graphite. So, graphite can be used as a lubricant. We know lubricant. It can be used in making electrodes as it's a good conductor of electricity. So these are few of the uses of graphite. No. Let's try to find out third allotropic form of carbon, which is fluorine, right? And in this particular, we'll be discussing C60. The C60 is called as Buckminster fluorine. Right? It has been given name. There was one architect, right, whose name was Buckminster. So on his name, they call this particular fluorine as C60. Basically, this fluorine, its concept was actually given by three scientists. One is H.W. Kroto. Second one is R.E. Smalley. Next one is R.F. Curl. They have designed this concept basically, right? Most of the students, when we ask them who designed this concept, they say that Buckminster Fuller. But basically, Buckminster Fuller, he was one US architect, right? Architect. You can check the spelling, right? Architect, right? He was simply an architect, and he has designed many domes, particularly geodesic dome, right? And these three actually, once they went to one conference hall whose dome was designed in the same way, and they basically got the concept of C60 from that. They basically draw the structure of C60 from that, right? And that dome structure, that was made by Buckminster Fuller. So that's why they call this particular type of fluorine as Buckminster fluorine. But the concept has been designed by these three. Let me tell you, the C60, it contains 20 hexagons. It contains 20 hexagons and 12 pentagons in one molecule, and 12 pentagons. It's also called as football structure, right? Buckyball structure. How actually it contains 20 hexagons and 12 pentagons? Like this way. This is one hexagon, guys. And this is one pentagon, right? So this way it has 20 hexagons and 12 pentagons in one molecule. Right? Right, guys? So that's all about the Buckminster fluorine, which is one type of fluorine. Now, we have the concept of hydrocarbons, right, guys? Okay, we have the concept of hydrocarbons. What are hydrocarbons? I can simply define compounds containing carbon and hydrogen. They are called as hydrocarbons, right? Simply, compounds containing carbon and hydrogen, they are called as hydrocarbons. Now look here, guys, how we actually classify these hydrocarbons. These hydrocarbons, they are generally classified into two categories. Category number 1 and category number 2. What is the first category? We call them as open chain hydrocarbons, right? And second one we'll be calling as closed chain hydrocarbons, right? And guys, if I talk about these open chain hydrocarbons, they are further classified into two categories. One I'll be calling as saturated hydrocarbons, and second one will be unsaturated hydrocarbons. And let me tell you guys, these saturated hydrocarbons are classified into alkanes, and these unsaturated hydrocarbons, they are classified into alkenes, 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 and alkynes, alkynes, right? In the same way, these closed chain hydrocarbons, they are classified into acyclic hydrocarbons, and second one, aromatic hydrocarbons. These aromatic hydrocarbons, let me tell you guys, these aromatic hydrocarbons, example is benzene, and these acyclic hydrocarbons, they are further classified into saturated, right? So closed chain hydrocarbons, they are classified as, or you can say cyclic hydrocarbons directly, right? Cyclic hydrocarbons or aromatic hydrocarbons. Cyclic hydrocarbons you can classify as saturated cyclic hydrocarbons and unsaturated cyclic hydrocarbons, right? And saturated cyclic hydrocarbons are classified into cycloalkanes, and unsaturated cyclic hydrocarbons, they are classified into cycloalkenes and cycloalkynes. This is the general classification of hydrocarbons. I hope this idea is clear, right guys? I hope this idea is clear. Let's try to find out one by one what are saturated hydrocarbons, what are unsaturated hydrocarbons, what are alkanes, what are alkenes, what are alkynes, what are their structures, what are the different compounds related to alkanes, alkenes, alkynes. Everything we'll be discussing in today's session. Now let's move ahead guys. Let us discuss the case of alkanes. One by one. Look here guys, if I talk about alkanes, there are few points that you need to remember about alkanes. But before that, we need to understand what are saturated hydrocarbons. Guys, saturated hydrocarbons are those hydrocarbons that contain a single bond, right? Right? Simple. Saturated hydrocarbons are the hydrocarbons that contain a single bond, and unsaturated hydrocarbons are the hydrocarbons that contain double or triple bond, right? If this is clear, then only we can understand the concept of alkanes. So what are alkanes guys? Let me write a few points. These are the saturated hydrocarbons. These are the saturated hydrocarbons which single covalent bond, right? Their general formula is, everything I'll make you clear guys, their general formula is CnH2n plus 2, right? Where N is number of carbon atoms. Clear? Their suffix that we'll be using is Ane, right? Clear? And they are also called as paraffins. Paraffins. They are also called as paraffins. Paraffins means they are chemically not very reactive. Because they only contain the single bond. And in order to break the single bond, we need more and more energy. So that's why they are chemically less reactive. I hope this is clear. Now let's try to find out what does these points mean, general formula and all that. But before that, we need to understand one more point guys, and that point is very, very important, right? What is that point guys? Try to understand. For example, if there is one carbon atom, if there is one carbon atom. For that we use a suffix, we use a prefix. We have few prefixes. If there is one carbon atom, we use the prefix as meth. If there are two carbon atoms, we use the prefix as eth. If there are three carbon atoms, we use the prefix as prop. If there are four, we use the prefix as but. If there are five carbon atoms, we use it pent. Right? In the same way, if there are six carbon atoms, we use hex. If there are seven carbon atoms, we use hept. If there are eight carbon atoms, we use op. If there are nine carbon atoms, we use non. If there are 10 carbon atoms, we use dec. Right? We use dec. Clear, guys? This is prefix. Clear? Now, I will write down one simple point. If you, this is one golden rule, right? This is one simple golden rule. If you double the number of carbon, and add plus 2, or add not plus 2, add 2, and add 2, you will get alkane. What does it mean, guys? Try to understand, you will get the idea. What does it mean? If you double the number of carbon, for example, guys, I am writing carbon and I am writing hydrogen. Imagine the carbon is 1. Look here. Imagine the carbon is 1. If what I am doing, if I will, let me write down it here. If I will write down carbon, this is hydrogen. If I will double this carbon, so what is the double of 1? It will be 2. And then I will add 2. What's the number 4? So CH4. I will get hydrocarbon. I will get an alkane. So how many carbons are there? 1. So we use meth. Since it belongs to alkane. And let me tell you, what is the suffix in alkanes? The suffix is 1. So it will be methane. In the same way, guys, if I have two carbon atoms, how many hydrogens will be there? Just double the carbon. What's the double of 2? 4. Add plus 2. It is 6. C2H6. In the same way, if I write down C3, what is the double of 3? 6 plus 2. 8. C3H8. In the same way, C4H10. In the same way, C5H12. Right, guys? That's how you get to know about the hydrocarbons. Now look here, guys. What I did? I mentioned if you double the number of carbon. Few minutes back I told you N represents number of carbon atoms. So what I am doing? Cn and hydrogen. What I am doing with hydrogen? I just double the number of carbon. 2n plus 2. Then add plus 2. That is the general formula of alkanes. That's what we did few minutes back. Cn H2n plus 2. Now look here, guys. For example, if I talk about octane in particular. So how many carbons are there in octane? 8 carbons. If you use the formula Cn H2n plus 2, right? So how many carbons are there? You can say, sir, 8. H. 8 into 2 is 16. 16 plus 2 is 18. C8H18. Now that you can do directly. No need to use the formula. But you have to remember the formula. Because you can clearly say, sir, it's 8. Just double 8. 16 plus 2. 18. Right? For example, decane. C10. H. What's the double of 10? 20. 20 plus 2 is 22. So this is how you get to know about alkanes. And let me tell you, first 10 alkanes are important for us. And you need to understand this is methane, and this one will be ethane, this one will be propane, this one will be butane, this one will be pentane, this one will be hexane, this one will be heptane, this one will be octane, this one will be nonane, and this one will be decane. Right? Now guys, let's try to find out few more things. In general, if I make a table, I will write down number of carbon. Right? I will write down the name. I will write down the formula. I will make the structure. I will make the condensed formula. And then the last one is electron dot structure. Right? These are few of the things that we need to understand. Guys, I will just take 2-3 examples, rest you can do it. For example, if number of carbon is 1, if for example number of carbon is 4, right? If for example number of carbon is 6, can you name it? We are talking about alkanes. We are talking about alkanes. If number of carbon is 1, we call it as methane. If number of carbon is 4, we call it as butane. If number of carbon is 6, we call it as hexane. Right? What will be the formula of methane? Image like I told you, CH4. What the formula of butane? C4. 488, 8 plus 2 is 10. What the formula of hexane? 6 double 12, 12 plus 2 is 14. C6H14. Clear? Clear guys? Now what about their structure? What about their structure? So carbon, it's bonded with hydrogen 1, 2, 3 and 4. Right? If I talk about butane, so 4 carbons are there, 1, 2, 3 and 4. Right? So this carbon already made one bond. How many more bonds this carbon can make? 3. 1, 2 and 3. This carbon already made 2 bonds. How many further bonds it can make? 1 and 2. This carbon made how many bonds? 1, 2. How many more bonds it can make? 1, 2. This carbon already made 1 bond. It can make 3 bonds. Right? That's the structure. In the same way guys, you can do C6H14. So how many carbon? 6. 1, 2, 3, 4, 5, 6. How many hydrogens? 1, 2, 3, 4, 5, 6, 7. 1 second. How many carbon? 6. 1, 2, 3, 4, 5, 6. How many hydrogen? 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. Right? Now let's try to make their condensed formula, which is very, very important. If I talk about the condensed formula, how will be writing? Directly write down carbon. How many hydrogens? 4. That will be the condensed formula. Write down the carbon separately. How many carbons? First one. With the first carbon, how many hydrogens are added? 3, CH3. Then single bond. Second carbon with it, 2 hydrogens. Third carbon, 2 hydrogens. Last carbon, 3 hydrogens. So this will be the condensed formula. CH3, CH2, CH2, CH3. In the same way, hexane guys. Can I say it's CH3? Single bond CH2, single bond CH2, single bond CH2, single bond CH2. Last one will be CH3. 1, 2, 3, 4, 5, 6. Right? Look here, from this we can conclude. Right? Done guys? After that, give electron dot structure. But before electron dot structure, let me show you one thing. If for example, they will ask you, calculate total number of covalent bonds in methane. Calculate total number of covalent bonds in methane. How many total bonds are in methane? You can say sir 1, 2, 3 and 4. Right? If I develop the general formula for it, try to understand guys. How many carbon are there? I can say number of carbon is 1. How many hydrogens are there? So carbon plus hydrogen. How many carbon are there? I can say 1. How many hydrogen are there? I can say 4. 4 plus 1 is 5. But how many total bonds are there? There are total bonds as 4. So I will minus 1. So general formula will be carbon plus hydrogen minus 1. Directly you can calculate the number of bonds. For example, how many bonds are in C4H10? No need to count. If you say sir 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13 bonds are there. So you can directly do it. Just do it directly. 10 plus 4 is 14. 14 minus 1 is 13. So carbon plus hydrogen minus 1 is the general formula to calculate the number of bonds. How many bonds will be there? 14 plus 6 is 20. 20 minus 1 is 19. So carbon plus hydrogen minus 1. Similarly, if I ask you, calculate the total number of bonds in, for example, C30, H62, right? So you can do it. Sir, carbon plus hydrogen. What's the number? 2. 6, 7, 6, 3, 9. 92 minus 1, sir, it's 91. So total number of bonds is 91. Because I use the formula carbon plus hydrogen minus 1. I hope this formula is super duper clear. Right guys? Now we have electron dot structure. How exactly I'll be doing electron dot structure of methane, right? I told you, just make the structure of methane. You will say, sir, C, H, H, H and H. Now look here guys, logically if I think this is carbon. This carbon is bonded with hydrogen, 1 hydrogen, 2 hydrogen, 3 hydrogen, 4 hydrogens, right? Very simple. And every single line represents one pair of electron. So can I say there will be one pair of electron? Can I say there will be one pair of electron? Can I say there will be one pair of electron? Can I say there will be one pair of electron? What does it mean one pair of electron? Can I say this hydrogen is stable in this way? That's what it means. This hydrogen is stable in this way. What does it mean? This hydrogen is stable in this way. This hydrogen is stable in this way. And as such, this carbon is stable in this way. This is the electron dot structure of methane, right? Check out 2, 4, 6, 8. Carbon 8, hydrogen 2, hydrogen 2, hydrogen 2, hydrogen 2. I hope this idea is super duper clear, guys. Yes? I hope this idea is super duper clear. Clear? Now, let's move ahead, guys. Let's move ahead. Let's now try to make the structure of C4H10. Few minutes back, I told you to draw the structure. So how many carbons are there? 1, 2, 3, 4. With the first one, how many hydrogens are there? 1, 2, 3. Second one, 1, 2. Third one, 1, 2. Last one, 1, 2, 3. Now just make the electrons. There's a single bond, everywhere single bond. Single bond means one pair of electrons. Single bond means one pair of electrons. Single bond means one pair of electrons. Single bond means one pair of electron. One pair of electron. One. This way one, this way one, this way one, this way one, this way one. One and one. Now make the circles. So carbon, hydrogen, 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 hydrogen guys, hydrogen guys, hydrogen guys. Hydrogen is stable everywhere, right? Hydrogen is stable everywhere. Now look here how this carbon is stable. This carbon is stable 2, 4, 6 and from this side 2 more carbons. So this carbon is stable in this way because this carbon, if I talk about this carbon, it is sharing one electron from this side, one electron from this side, one electron from this side and one electron with this carbon. In the same way this carbon 2, 4, 6 and 8. So this carbon is also stable in this way, right? In the same way guys, if I talk about this carbon, this is also stable in this way, right? 1, 2, 3, 4, 5, 6, 7, 8, right? This is one electron. If I talk about this carbon, this particular carbon, it is stable in this way, right? It is stable in this way. 2, 4, 6 and 8. That's how you can make the electron dot structure of butane, right? You can make the electron dot structure of pentane as well. I hope this thing is clear, guys. Everything I told you, I guess, right? About alkanes, everything is super clear, guys. Yes, everything is super clear. They are also called as paraffins. The general formula I have discussed, right? Electron dot structure I have discussed. Now, let's switch on to alkanes. Before alkanes, let me get some water. Okay guys, alkenes. Now if I talk about alkenes in simple, if I talk about alkenes, can I say that these are the unsaturated hydrocarbons? Yes, these are the unsaturated hydrocarbons, unsaturated hydrocarbons containing double bond, right? Alkenes, they contain double bond. If I talk about their general formula is CnH2n, where n is the number of carbon atoms, right? If I talk about their suffix I'll be using as ENA. Clear? And the last point, they're also called as olefins. OLE. They're also called as olefins, oil forming, right? OLEFFINS. Olefins, oil forming. I hope this idea is clear. Now again guys, let me write down this golden rule so that you can clearly identify. The golden rule is, if we double number of carbon, and it's true for hydrogen basically, right? If we double number of carbon, For hydrogen basically, right? With double number of carbon we get alkene. That's one golden rule. Now guys, let's try to find out. For example, if I talk about in the same, if I make a table, number of carbon, right? Again, then it will be its name. Again, its formula, right guys? Again, structure. Again, condensate structure, and again it will be electron dot structure, right? Electron dot structure. I hope the idea is clear. I hope the idea is clear, right? Guys, try to find out. If number of carbon is 1, for that we need to understand. Before I will move ahead, guys, I need to understand few things. If number of carbon is 1, so this is carbon, only carbon atom is 1. It can make single bond with hydrogen, but in order to make a double bond, it needs one more carbon. So the minimum carbon requirement here is 2 carbon atoms. How many carbon atoms? 2 carbon atoms. Guys, for example, if I have one carbon atom, only one carbon atom, what I call this compound? Sir, one carbon atom means meth. And if this is alkene, for example, we'll call it as ENE at the last. I told you the suffix that we are using is ENE. So what will be the name of the compound? Methane. But methane does not exist. Methane guys, it does not exist, because minimum how many carbon atoms are needed in case of alkenes is 2 carbon atoms, and meth means only 1 carbon atom. That's why methane does not exist. We need 2 carbon atoms to make a double bond. Clear? So that's why we directly start this number of carbon with 2, right? Similarly there will be 3, similarly there will be 4, 5, 6, 7, so on, right? What will be the name of the compound, guys? 2 carbons are there, so F. What is the suffix that we are using is ENE, ethene. This will be propene. This will be butene. This will be pentene. This one will be hexene. This one will be heptene. This one will be octene in the same way, right? And what would be the formula? We know that with the general formula, CnH2n. So what we have to do, guys? What we have to do? For example, ethene means 2 carbon. So C2H2. N means 2. So C2H2 plus 2 is 4. So the formula will be C2H4. But we can do it directly by means of golden rule. I told you what you have to do. Ethene means 2 carbon. Just double it. It will be 4. Propene means 3 carbon atoms. Just double it. 6. Butene means 4. Just double it. 8. Pentene means 5. Just double it. 10. Hexene means 6. Just double it. 12. Heptene means 7, just double it, 14. That's how you can do it with the help of golden rule. Now, let's try to make the structure, guys. Let's try to make the structure of ethene. How many carbons are there? There are 2 carbons. Now, between the carbon atoms, there is a double bond. So, there can be double bond this way. Now, carbon already made double bond. How many further bonds carbon can make? So, it can make 2 bonds. So, 1 bond and 1 bond. How many bonds? 1 bond and 1 bond. Because already it has made how many bonds? Yes, guys. It already has made 2 bonds, right? So how many hydrogens? 1, 2, 3, 4. Look here. If I draw the structure of, for example, pentene, guys, look here. Pentene, for example. How many carbons are there? 5. So I can say 1, 2, 3, 1, 2, 3, 4, 5. Just make a double bond at any place. For example, I'll make double bond here. Now tell me, guys, how many bonds this carbon already made? Sir, 1, 2 bonds. How many further bonds it can make? 2 bonds. So 1 bond and 1 bond. How many bonds this carbon already made? 1, 2 and 3 bonds. How many further bonds it can make? Only 1. Because this carbon made 1 bond from this side. Similarly, at every place you have to keep the single bond. At only one place you have to keep a double bond. Right? So how many bonds? This carbon can make 2 bonds. 1 and 2. This carbon 1 and 2. And this carbon 1, 2 and 3. Just count the hydrogens. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. How many hydrogens are there? 10 hydrogens are there. Now guys, if I try to make its condensate structure, the first one, how exactly are we making the condensate structure? Can I say it's CH2, right? Double bond CH2. Done and dusted. If I try to make its condensate structure, this one. How many carbons are there? 1, 2, 3, 4, 5. So first carbon is linked with how many hydrogens? 2. Then double bond. This carbon is linked with how many hydrogens? Only 1. Then single bond. Then there will be CH2. Then there will be CH2. Last one will be CH3. Right? I hope this thing is clear. I hope guys this thing is clear. The condensed structure is clear. Right? Have this thing is clear. Now can you draw the electron dot structure? For example, if I show you the electron dot structure of first one, or if I show you the electron dot structure of anyone, you can do it. For example, if I do the electron dot structure of ethene, ETHENE. So guys, how many carbons are there? 1, 2. And how many hydrogens are there? There is one hydrogen, there is one hydrogen, there is one hydrogen, there is one hydrogen. Now just make the dots. For hydrogen there is one dot, for this hydrogen there is one dot, for this hydrogen, for this hydrogen. Now this carbon is how many electrons? 4 I can say. So there will be, I'll make it with cross. 1, 2, 3 and 4. This carbon 1, 2, 3 and 4. Now here you need to keep it in your mind that this time this carbon shares one electron with the hydrogen, this hydrogen is stable, shares one electron with the hydrogen, this hydrogen is stable, this carbon shares one electron, stable, this carbon shares one electron, stable. But now the thing is, this carbon is making double bond with this carbon, means it's sharing how many electrons? Here it's sharing 2 pair of electrons, right? So this carbon, 2 from this side, 2, 4 and 4 from this side, right? This way. This carbon 2, 4 and 4 from this side, right? Because guys, this carbon has single bond with the hydrogen. Single bond with the hydrogen. This carbon has single bond with the hydrogen. Single bond means one pair of electrons is being shared. But between carbon and carbon there is a double bond. Double bond means how many pair of electrons they are sharing? 2 pair of electrons they are sharing. In the same way guys, you can do it for others. Right? What if they will ask you? What if guys they will ask you, for example, I am taking the example of butane or I am taking the example of ethane. Take the example of ethane. How many bonds are present in ethane? Guys, try to find out the bonds. Can I say 1 bond, 2 bond, 3 bond, 4 bond, 5 bond and 6 bond? Right? So how to calculate the bonds? Directly carbon plus hydrogen. Directly carbon plus hydrogen. How many carbon? 2. How many hydrogen? 4. 4 plus 2, 6. So total number of covalent bonds is 6. 1, 2, 3, 4, 5, 6. What if they ask you how many total covalent bonds will be present in C6H12? Just add carbon plus hydrogen. How many carbon guys? 6. How many hydrogen? 12. 12 plus 6 is 18. Right? How many total covalent bonds are present in 13? 7 plus 14. So 14 plus 7 is 21. I hope this thing is clear as well. I hope this thing is clear. Now let's answer the question, why is not the first member of alkene known as methane? That already we discussed, right? Now we have alkynes. Guys, we have alkynes. What are alkynes now? You should know it. You should know it guys. They contain triple bond, right guys? They contain triple bond. Point number 1, the general formula is CnH2n minus 2. Point number 3 guys about these alkynes is that they are also called as acetylenes, right? Acetylenes, because the name of the first member is acetylene, right? That's why they are also called as acetylenes. Very simple. What's the golden rule? For example, if there are 4 carbons, imagine how many hydrogens will be there? Just double 4. So double carbon minus 2. That's it. So 4's double is 8. 8 minus 2 is 6. That's how you directly identify whether anything is alkane, alkene or alkyne. Now before I will make you clear this in detailed manner, can you answer few of the questions? For example, if I am writing C20 H40, I am writing for example C40 H80, I am for example writing C30 H62, I am for example writing C90 H180. Similarly, I am writing for example, just give me a minute, C50 H98 for example. Similarly, I am writing C70 H142. Similarly, I am writing C80 158. You have to identify which one is alkane, which one is alkene and which one is alkyne. Let's talk about this one directly. How you can identify? Just double 50. 50 is double is 100. And then there is minus 2. So, alkyne. Y-N-E. Done? 20 is double 40. E-N-E. Alkene. Yes. 30 is double is 60. 60 plus 2 is, yes, ANE, alkane, right? 70 is double, 140 plus 2, so alkane. 40 is double is directly 80, alkene. 90 double directly 180, alkane. 80 double is 160. 160 minus 2 is 158. So it's YNE, alkyne, right? You need to check these, right? And guys, here one point I'll be adding. What will be the suffix? The suffix here will be YNE, right? In the same way, in the first case, like I told you, methane does not exist. Here, methane does not exist, right? Why? Because it needs one more carbon with which it can make a triple bond, right? It can make a triple bond. For example, guys, this carbon, it's making triple bond with the carbon. Now tell me, this carbon made how many bonds? 1, 2, 3. So it can make one bond with the hydrogen. It can make one bond with the hydrogen. So how many carbons are there? 2. How many hydrogens are there? 2. Look here, 2 is double is 4. 4 minus 2 is 2. So we have C2H2, right? And this particular compound is called as ETHYNE, ethyne. I hope this thing is clear. Now let's try to make a table again. Again, guys, let's try to make the table. Let's try to make the table. Okay. So table I am starting number of carbon. Yes. Then there will be name. Then there will be formula. Then there will be structure. Then there will be condensed formula or condensed structure. Then there will be electron dot structure. I hope this thing is clear, right? I hope this thing is clear, guys. Okay. If number of carbon, I'll be starting with 2. Then it can be 3. Then it can be 4. Then it can be 5, 6, 7, 8, 9, 10. Right? Name will be 2 carbon means F, E, T, H. Then it will be YNE, ethyne. 3 carbons will be prop, prop, YNE. 4 will be but, YNE, butane. 5 will be pent, PNT, pent, YNE. In the same way, if I have 10 carbon atoms, it will be DECYNE, decyl, right? Decyl, right, guys? Formula. The general formula is CnH2n minus 2. You can use the general formula, but you can do it directly. How many carbons are there? 2. Just double it. 2 double 4. 4 minus 2 is 2. Propane. How many carbon? 3. 3 double is 6. 6 minus 2 is 4. Butane. 4 double is 8. 8 minus 2 is 6. Pentane. 5 double is 10. 10 minus 2 is 8. Decyl. C10. 10 double is 20. 20 minus 2 is 18. Right? So these are the formulas. What about the structure now? What about the structure? For example, if I talk about ethyne, guys, how many carbons are there? 2 carbons are there, carbon 1 and carbon 2. Between these carbons, there is a double bond. So carbon already made 2 bonds. How many further bonds it can make? 2 bonds, 1 and 1 here. This carbon can make 2 bonds, 1 and 1 here. Right? This is ethyne. In the same way, guys, let's talk about butane. Let's talk about butane directly. How many carbons are there? 1, 2, 3 and 4. Put triple bond randomly anywhere. For example, I'll put it here. And then single bond every time. Right? Now tell me, guys, how many bonds this carbon can make? 1, 2, 3. It can make 1 bond. How many bonds this carbon can make? 1, 2, 3, 4. No bond. How many this? 2. How many this carbon? 2, 3 bonds. 1, 2 and 3. Right? This thing is clear. This thing is clear. Quite clear. Right? If I try to make their condensed structures now. If I try to make their condensed structures. For example, what will be the condensed structure of this? How many carbons? 2. First carbon is linked with 2. Oh, sorry. 1 second. 1 second, guys. There's a slight mistake, right? Just few minutes. Last case what I showed. Okay, last one is clear. Okay, look here, guys. So carbon is bonded with carbon. How many bonds? Triple bond. So there will be further 1 bond. There will be further 1 bond, right? That we need to clear. Sorry. Let's try to find out. This carbon is bonded with hydrogen. Triple bond CH, right? Or you can sometimes find it written in the books HC triple bond CH, right? That's also correct. Right, guys? That's also correct. Done? Okay. Now look at this one, butane if I talk about. So first carbon is linked with how many hydrogens? 1. Then there will be triple bond. Second carbon. Then CH2. Then CH3. 1, 2, 3. 1, 2, 3, 4, right? This will be the structure, or you can find it in the books written as sometimes HC triple bond C triple bond CH2 single bond CH. This type of structure, right? I hope this thing is clear as well, right, guys? Right? Now, what about your electron dot structure? Let's take the case of, for example, propine. Let's take the case of propine. PRO, propine. So in propine, how many carbons are there? 3. How many hydrogens will be there? 3 is double is 6. 6 minus 2 is 4. Let's start with that structure, guys, first of all. So carbon, carbon, carbon. Put a triple bond here. How many hydrogens will be here? 1. How many hydrogens will be here? No. How many hydrogens will be here? 3. 1, 2, 3. So 1, 2, 3, 4 hydrogens. Then, if I try to make structure, guys, quite simple. How I'll make it structure? I will say this is carbon 1, carbon 2, carbon 3, and this one will be carbon 4, right? Right, guys? If I am putting triple bond here, so how many hydrogens will be here? Only one hydrogen will be here. Then if I put single bond here, so there will be no hydrogen. How many hydrogens will be here? 2 hydrogens. How many hydrogens will be here? 3 hydrogens. That a few minutes back showed you in this way, right? So 1, 2, 3, 4, 5, 6 hydrogens, right? 6. Oh, sorry, I'm talking about butane, right? Let's talk about not propane. I made 4 carbons, so it will be butane. B-U-T-Y-N-E. So in butane, how many carbons will be there? 4. How many hydrogens will be there? 4 plus 4 into 2 is 8. 8 minus 2 is 6. So 1, 2, 3, 4, 5, 6, right? Okay. Now distribute the electrons. Can I say this carbon has 1, 2, 3, 4? This carbon has, right? In the same way, this carbon has 1, 2, 3, and this carbon has 1, 2, 3, and 4, right? This carbon has 1, 2. Oh, wait 1 second. 1, 2, 3, and 4. 1 second. I'll erase these 2 dots. Alright, guys. This carbon has 1, 2, 3, and 4. Now look here. How exactly I'll be making these bonds, right? So this hydrogen is stable, guys. This hydrogen is stable. This hydrogen is stable. This hydrogen is stable, right? Because they have 1, 1. They have 1, 1, right? So they are stable. This hydrogen is stable at the same time. Yes. This hydrogen is stable at the same time. Now look here. If I talk about this carbon shared 1 electron with the hydrogen. So 1, 2. And from this, how many will it be sharing? So it will be sharing 1, 2, 3. And with this carbon will be sharing its 3. 1, 2, 3. Right? Let me erase these 3 electrons here. So can I say that this carbon is stable now? Look here. 3, 1, 2, 3, 4, 5, 6, 7, 8. Right? Now look here about this carbon. This carbon. This dot, it will be sharing with this carbon. From this it will get 1. From this carbon, try to understand. From this carbon it will get 1. So 1, 2, 3, 4, 5, 6, 7, 8, 8. So this carbon will be stable. Right? Now this particular carbon is stable. Now let's talk about this carbon. So this carbon shared 1, 2, 3, and it has only 1 left. Why 2? Just put only 1 here. So now look here. With this carbon it will share 1, and this way it's stable. Right? So 1, 2, 3, 4, 5, 6, 7, 8. In the same way, this carbon is stable. 2, 4, 6, and 8. Right? So this carbon is stable at the same time. I hope this idea is clear, guys. Yes. So this butane is stable at the same time.
Yeah, exams.
Exam? 2 minutes. Okay. Okay.
No. Not super, right? Move the chair. This. No, move the chair.
Done?
No.
Okay. So that way this butane is the electron dot structure of this butane. I hope this is clear at the same time, right?
No, I just saw your dad and I got
Well done.
Okay, guys. Now, electron dot, so this is clear at the same time. Let's now move ahead. Now we have cyclic or closed chain hydrocarbons. Okay. Now, what are cyclic compounds or what are closed chain hydrocarbons? For example, if I simply talk about cycloalkanes, right? So simplest one will be cyclopropane, right? Why cyclopropane will be simplest? Because you have to make a chain. And for making chain, guys, what I'll be doing? This carbon, I will be attaching with how many carbons? Right, this way, to make a simple chain, right? Now, every time there's a single bond, so I'll be calling it as cycloalkane, right? Because there's a single bond every time. And if this carbon need two bonds, how many further bonds it can make? Two bonds with the hydrogen. This carbon two bonds with the hydrogen. This carbon two bonds with the hydrogen. And let me name this compound as cyclo. How many carbons? 1, 2, 3. 1, 2, 3 means prop. And every time single bond means ane. So the name of the compound will be cyclopropane, right? Clear, guys? In the same way, for example, if I have 4 carbons, 1, 2, 3 and 4. Every time there is a single bond, right? If there is a single bond, now there will be double 2 bonds, there will be 2 bonds this way, right? So how many carbons are there? 4. How many hydrogens are there? 2, 3, 4, 5, 2, 4, 6 and 8, right? 2, 4, 6 and 8. What I will name this compound? How many carbons are there? Since it's a cyclic compound, so I will name it as cyclo, right? So how many carbons are there? 4. So butane, cyclobutane. So you can make cyclobutane this way as well. You can make cyclopropane this way as well. And this particular compound is called as cyclohexane. This particular compound is called as cyclopentane. This is clear. And let me tell you guys, their general formula is CnH2n, same as that of alkenes. That's their general formula. You can check out how many carbons? 4. How many hydrogens? 8. Just double it. Right? They are cycloalkenes. Similarly, if I talk about cycloalkenes now, right? For example, the simplest cycloalkene will be this way, right? There will be a double bond. That's it, guys. So look here. At every point there is carbon. Now, at one place I am putting a double bond. At one place I am putting a double bond. That's it. And here I'll put a single bond. Here I'll put a single bond. Clear? If this carbon has made double bond, 1, 2, and here 1 bond, 3 bonds already. How many further bonds it can make? Only 1 bond, right? CH. This carbon made how many bonds? 1, 2, 3. So it can make 1 more bond. This carbon 1, 2, it can make 2 bonds. Clear? Now how many carbons are there? 3 carbons. How many hydrogens? 2, 3, 4. Right? So guys, their general formula is CnH2n minus 2. Right? The general formula is, see, what's the double of 3? 6. 6 minus 2 is 4. So CnH2n minus 2. And what's the name of this compound? Again, this will be cyclo. How many carbons are there? 3. 3 carbon means prop. Since there is double bond, I will be using ENE. So cyclopropene. I hope this is clear, guys. Yes. In the same, if I make one more structure this way, at one place I will keep a double bond, right? Now there is carbon. At one place double bond, then single bond, and single bond, right? Clear? So this carbon made how many bonds? 1, 2 and 3. It can make 1 more bond. This carbon 1, 2, 3. It can make 1 more bond. This carbon 1, 2. It can make 2 bonds. This carbon 1, 2. It can make 2 bonds. Right? From the general formula, you can also confirm the number of hydrogens. Right? CnH2n minus 2. So basically, how many carbons are there? Yes, there are 4 carbons. Just double 4. 4 double is 8. 8 minus 2 is 6. C4H6 it will be, right? 1, 2, 3, 4, 2, 4, 5, 6. 2, 4, 5 and 6. C4H6. What's the name of this compound? It will be cyclo. So 4 carbons. But. And then it will be it will be butene. ENE. Right? Butene. In the same way, guys, if I do some change, right? If I do some change now, right? If I do some change now, right? What happened? Once again, this one. If I do some change now, yeah. If I do some change now, if I put a triple bond here, imagine guys, now I put a triple bond here. If I put a triple bond here, can you just confirm once? Can you just confirm once? If this carbon made 3 bonds, 1, 2, 3, and from this side 1 bond, will there be any hydrogen? No. So there will not be any hydrogen. There will not be any hydrogen. So carbon triple bond, this carbon. Now this carbon made how many bonds? This one. 1, 2, 3. From this side 1. Will there be any hydrogen? No, there will not be any hydrogen. This carbon made how many bonds? 1, 2, 3, 4. This carbon made how many bonds? 1, 2. There will be 2 hydrogens. Clear? And guys, can you just write down how many carbons are there? 3 carbons. And how many hydrogens are there? Yes, 2 hydrogens. So general formula will be CnH2n minus 4, right? In case of cycloalkynes, ALKYNES. This is cycloalkyne. Why cycloalkyne? Because there is a triple bond. There is a triple bond, guys. So there's a triple bond. That's why I'll be calling this compound as cycloalkyne. And what will be the name of this particular compound, right? Check out. If you use the general formula, so C3 double is 6. 6 minus 4 is 2. So what's the name of this compound? How many carbons are there? 3. So 3 carbon means pro. And every time there is a triple bond. Why any? So cyclopropyne, right? At one place there's a triple bond. In the same way, guys, if I place a triple bond here, for example, this particular compound I'll be calling as cyclo. Yes, this is the same compound. Right now, if I put a triple bond here, for example, so this particular compound I'll be calling as cyclobutane, right? And remember here it will be carbon, carbon. This carbon made 4 bonds. This carbon made 1, 2, so here will be says 2. 1, 2, here will be says 2, right? So how many carbons? 4 carbons are there. If you use the general formula, 4 carbons, how many hydrogens will be there? 4 double is 8. 8 minus 4 is 4. So there will be 4 hydrogens. See, 2 and 2, 4 hydrogens. I hope this thing is clear, right? Since I am moving a bit fast, because this is quite easy, right, guys? Now, let's now move ahead. Let us discuss the structure of benzene, which is an aromatic compound, right? Benzene is actually an aromatic compound. Clear? And how actually I'll be drawing the structure of benzene? Let me tell you, benzene contains 6 carbon atoms. Point number 1. It contains 6 carbon atoms. And one more point about benzene is it contains alternate single and double bond. It contains alternate single and double bond. How exactly? This is the structure of benzene. 6 carbon atoms, right, guys? Yeah. And there will be double bond, then single, then double, then single, then double, right? Clear? Now see, every point represents carbon. How many bonds is carbon made? 1, 2, from this side 1, 3. 3 bonds. So how many further bonds it can make? 1 with the hydrogen. Look at this carbon. How many bonds? 1, 2, 3. So 1 more bond. How many bonds is carbon? 1, 2, 3. How many more bonds? 1. This carbon, 1, 2, 3. How many more bonds? 1. How many bonds? 1. How many bonds? 1. Right? So how many carbons? 6. How many hydrogens? 6. That's the structure of benzene, right? So they can ask you to directly draw the structure of benzene in your examination. You can clearly draw. It's an aromatic compound. At the same time, guys, it has 6 carbon atoms and it has 6 hydrogen atoms. It contains alternate single and double bonds. Clear? Done? Let's now move ahead. Let's discuss the case of isomerism. What do you mean by isomerism? Substance having same molecular formula but different structural formula are said to be isomers of each other, and the phenomenon is known as isomerism. What does it actually mean? Try to understand. Guys, for example, if I talk about butane, right? Simple butane if I talk about. So butane is C4H10. Let's try to draw the structure of butane. Can I say that such the structure will be 1, 2, 3 and 4 carbon, and there will be 1, 2, 3, 4, 5, 6, 7, 8, 9 and 10 hydrogens. That's one way. One more way I can do, I can just put 3 carbons in the main chain. 1, 2, 3 carbons in the main chain, right? That's one more way. And 1 carbon I will place here. 1 carbon I will place here. And then how many hydrogens? 1, 2, 3. How many hydrogens? 1. How many hydrogens? 1, 2, 3. Why only one hydrogen here? Because 1, 2, 3 bonds are ready. This is hydrogen, 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 hydrogen. This is one more way, right? Now look here. What is the formula of this butane? Can I say there are 4 carbons and 10 hydrogens? Yes, formula is same. What about this? 1, 2, 3, 4. 4 carbons, how many hydrogens? 1, 2, 3, 4, 5. Okay, this hydrogen will be connected with 3 more. 1, 2, 3. So how many hydrogens? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Is the formula same? Yes. Now there is difference in the structure. You can check out, there is a difference in the structure. Whenever we have such type of compounds wherein there is the same formula but the structural difference is there, we call these compounds as isomers, and this phenomenon is known as isomerism. Now guys, if you have to name these compounds, how you'll be using the IUPAC nomenclature to name these sort of compounds? Look here guys, how many carbons are there? 4. So for 4 carbons we use but, right? ANE, butane, or normal butane we call this as. Now this particular compound, it's also called as isobutane. It's also called as isobutane. Now look here, how you name it as per the IUPAC nomenclature. As per the IUPAC nomenclature, we have to select the longest carbon chain, and this is the longest carbon chain guys. In this longest carbon chain, I have to do numbering. Now look here, the carbon which is separated from the main chain, so this is the main chain and this carbon is separated from the main chain. This particular carbon will be calling as substituent. Right? Substituent. And here the substituent is CH3. Look here, the substituent is CH3. Guys, we call this CH3 as methyl. You should know it. We call this as methyl. For example, if I take methane, look here guys. Let me tell you here. For example, here, look here. If I talk about this methane, this is methane, right? It is CH4. Now guys, imagine I will be removing one hydrogen from it. I will be removing one hydrogen. What I will get? CH3, right? The CH3 I will be calling as methyl. Imagine from this C2H6, I will remove one hydrogen. What I will get? C2H5, right? This I will be calling as ethyl. Similarly, propyl, butyl, pentyl, hexyl, heptyl, octyl, nonyl, and decyl, right? Correct, right, guys? Okay. Now look here, this particular compound, how I will be naming it. So this is called as substituent, and I have to number it. I will number in this way 1, 2, 3, or I can number in this way 1, 2, 3. Now both ways substituent is getting 2. We have to do numbering in such a way that substituent should get the lowest number. Now both ways substituent is getting 2. So now clear. Now how I will be naming it, guys? So very simple. Clear? How many carbons are in the main chain? 3 carbons. 3 carbons are in the main chain. 3 carbon means prop. Right guys? This is called as prop. And that's a single bond everywhere. We call this as propane, right? At position number 2, there is methyl group. So I'll say that it is 2. Then dash. Number and alphabet, they are separated by dash. 2-methyl propane, right? Because at position number 2 there is a methyl group, so I'll be calling this as 2-methyl propane. Done guys. After that we have structural isomers of pentane, and pentane, isopentane, and neopentane. It has 3 structural isomers. How I'll be making its 3 structural isomers? The first one will be normal. How many pentanes are there? How many carbons? 1, 2, 3, 4, 5. So hydrogen 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Because it is C5H12. That's one structure, guys. Just put hydrogens at every point. Hydrogen. This is called as normal pentane. This is one structure, right? Normal pentane. Let's try to make it one more structure. How many carbons I'll put in the main chain? 4. 1, 2, 3, and 4. 1 I'll put here, right? 1 I'll put here. And put the hydrogens now. 1, 2, 3 hydrogen. 4, 5, right? 6, 7, 8. Done. 1, 2. Yes, 3, 4, 5, 6, 7, 8. Where we did wrong, guys? 1, 2, 3, 4. 4 carbons are there, right? Single bond is there. So there is one more, right? Okay. Done now. Now it's C5H12. I hope the idea is clear. That's one way. Now, if I have to name it, if I have to name this compound, how I'll be naming it? But before that, I'll make one more structure. Now, I'll just put 3 carbons in the main chain, 4th one here and 5th one here. This is called as neopentane that I will tell you. Look here. Here, how many carbons? 1, 2, 3, 1, 2, 3, 1, 2, 3, and this one will be 1, 2, 3. So 3, 6, 9, 10, 11, 12. Right? So this one I told you it's called as normal pentane simply. If I talk about this one, just do the numbering. I can do numbering in this way 1, 2, 3 and 4, or I can do numbering in this way 1, 2, 3 and 4. I told you numbering should be done in such a way that substituent should get the lowest number. If I do numbering this way, substituent is getting the number 3. This is substituent. It's getting number 3. If I do numbering in this way, substituent is getting number 2. So which is the best way of numbering from this side? Now tell me guys, how many carbons are in the main chain? 4. 4 carbon means bute. Every time there is a single bond, I can say butane. Now at which position there is a substituent attached? At 2, so I'll be calling this as 2-methyl butane. I hope this is clear. Now guys, let's name this compound, right? So every time there are hydrogens, right? I'll do numbering 1, 2, 3. How many carbons are in the main chain? 3. 3 means prop. Every time single bond, so propane. At position number 2, can I say there is one methyl group? There is one more methyl group. So there are 2 methyl groups. So I can name it as in this way: 2, 2 dimethyl propane. Okay, number is separated by dash if there is letter and number, and if numbers are there, they are separated by comma. Right? So 2, 2. Because at 2 there are 2 methyl groups, dimethyl. So 2, 2 dimethyl propane will be the name of this neopentane. Then after that we have structural isomers of hexane. If I make the structural isomers of hexane, how exactly I'll be making? So for that the first structure will be carbon 1, 2, 3, 4, 5 and 6. Guys, I will not write down H. It's understood that every line has H attached with it, right? This particular structure I'll be calling simply as hexane, right? Hexane, normal hexane and hexane. This is one. Second one, I'll put 5 in the main chain. 1, 2, 3, 4, 5. And 1 I will put here. Rest hydrogens are there. Hydrogens are there, guys. Rest hydrogens are there. Now I have to name this compound. How exactly I'll be naming this compound, guys? Look here. How many carbons are in the main chain? 1, 2, 3, 4, 5. 5 means pentane, right? Pentane. I hope this idea is clear. Now tell me, if I do the numbering, if I do 1, 2, 3, 4, substituent will get 4, but if I do this way, substituent will get 2. Can I say that it will be 2-methyl pentane? Very simple. That's one more structure, right? One more structure I can make here. So how many carbons are there? So 1, 2, 3, 4, 5. 1 carbon I'll put here. Done, guys. 1 carbon I'll put here. Let's do the numbering now. Can I say this is 1, 2, 3, 4, 5? If I do numbering from this side, 1, 2, 3. Substituent will get again 3. So what will I name this compound? 3-methyl. Now the methyl group at position number 3. 3-methyl, and there are 5 carbons in the main chain, 3-methyl pentane. This is one more structure. The first structure, second structure and third structure. It has 5. Let's try to find out fourth one. How I'll make fourth structure? Look here, guys. Again carbon. How many carbons? 1, 2, 3, 4. 5 and 6 carbon I'll put here. Right? This is one more structure. Its one more structure will be 1, 2, 3, 4. 5th carbon is here, 6th carbon is here. Right? That's the maximum possibility of structures it can have. Right? That is the maximum possibility of structures it can have. Now let's name them. Let's name them, guys, one by one. How I'll be naming them? So I'll number it 1, 2, 3, 4. Can I say at position number 2 there are 2 methyl groups? You can clearly say yes. So I can say 2, 2 dimethyl. 2, 2 dimethyl. How many are in the main chain? 1, 2, 3, 4. So butane. 2, 2 dimethyl butane. Then if I talk about this one, if I particularly talk about this one, I can number it 1, 2, 3, 4, or you can number it 1, 2, 3, 4, 1 and the same thing. Now this time, can I say at position number 2 there is methyl group, as well as at position number 3 there is methyl group. So I can name it as 2, 3 dimethyl. How many carbons are in the main chain? 1, 2, 3, 4. 4 mean butane. 2, 3 dimethyl butane. This one is 2, 2 dimethyl butane is 2, 3 dimethyl butane, right? So this one will be structure number 4 and this one will be structure number 5. So it is 5 structures. Take a note of all these 5 structures. They can directly ask you 1, 2, 3, 4, 5, and these are isomers. See, every time the formula will be same. Every time 1, 2, 3, 4, 5, 6. C6H14. Every time there will be C6H14. Now guys, let us switch on to one more topic, that is functional group. How I will be defining the functional groups. Right? How I will be defining the functional groups. An atom or group of atoms present in a molecule which largely determines its chemical properties are called functional groups. For example, I have methane. CH4 is methane, right? Very simple thing. This CH4 is methane, right? So can I say this is carbon bonded with hydrogen, bonded with hydrogen, bonded with hydrogen, bonded with hydrogen. If I remove this hydrogen, imagine I am removing this hydrogen, and in place of this hydrogen I am using chlorine, Cl. So what I will get? I will get a compound CH3Cl. This particular compound is called as chloromethane. Now, this chlorine will largely determine the properties of methane. Since it's methane, now I am adding chlorine. Now this chlorine will largely determine its chemical properties, and this chlorine I will be calling as functional group. I hope the idea is clear. Yes. Now we have few types of functional groups. One functional group I will be calling as halo group. A halo group refers to a functional group that contains a halogen atom. Halogen atom can be, yes, halogen atom can be chlorine, it can be fluorine, it can be iodine, it can be bromine, right? Or bromine. For example, guys, if I write down, I have CH4, just write down CH3Cl, you can write down. Or I can write down CH3Br, I can write down. I can write down CH3I, I can write down CH3, yes, F. Now this particular compound I will be calling as chloromethane. This one I will be calling as bromomethane. This one I will be calling as iodomethane. This one I will be calling as fluoromethane. Now this is one particular type of functional group, and this is called as halo group because it contains halogen atom. Chlorine is halogen atom, bromine is halogen atom, iodine is halogen atom, or fluorine is halogen atom. While naming these compounds, we just have to replace chlorine with chloro, bromine with bromo, iodine with iodo, fluorine with fluoro, right? Second functional group is alcohol group, guys, or hydroxyl group. So it contains, what does it contain? Let me tell you, it contains oxygen which is bonded covalently to a hydrogen atom, and this group is attached to a carbon atom within an organic molecule. What does it mean actually? Right? What does it actually mean? What does it actually mean? It means this alcohol group, it contains OH, right? And this O is covalently bonded with hydrogen. Since oxygen makes two bonds, so one from this side, one from this side. And from this side, this OH will be attached with that methyl, ethyl, propyl, butyl, pentyl, hexyl. For example, I will write down CH3OH, right? For example, guys, there will be OH. It will be attached with C2H5. This is methane, but there is lack of one hydrogen, and that is filled with OH, right? This is ethane. There is lack of one hydrogen, that's filled with OH. Similarly, guys, I will write down C3H7OH. Right? Clear? And if you have to name these compounds, what we'll be doing? In order to name these compounds, we have to use OL at the end. That's it. For example, if I talk about methane, METHANE. This is methane, right? Methane means one carbon is there, right? Methane means CH4 is there, right? Now remove one hydrogen, or replace it with OH, I can get CH3OH, right? So how many carbons are there? 3 carbons, so just write down methane. Now replace E with OL, so what will be the name of the compound? Methanol. Similarly, guys, if I have ethane, for example, what's ethane? C2H6. Replace one hydrogen with OH, what I will get? C2H5OH. What's the name of the compound? Since it's ethane, ETHANE. So remove E with OL, so it will be ethanol. Similarly, you have propanol, butanol, pentanol, hexanol. I hope this idea is clear. Now we have one more group, that is aldehyde group. This is also called as CHO group. And how you represent it? You represent it C double bond O single bond H, or you can represent it C double bond O single bond H, right? So it contains C double bond O. This particular C double bond O part is called as carbonyl group, right? It's called as carbonyl group. Clear? The C double bond O is called as carbonyl group. So this functional group, aldehyde group or aldehyde group, it contains a carbonyl group. Clear? And also it contains hydrogen, right? Again, guys, if I talk about same methane, ethane, propane, clear? If I talk about, for example, I will talk about propane right now. Propane, PROPANE. So what's propane? C3H8. If you remove one hydrogen, what you will get? C3H7. Now in place of that hydrogen, just add this group, CHO group. So write down CHO here. Clear? Write down CHO here. So basically you will get what? You will get one functional group or aldehyde group. Clear, guys? That you can do. Now let's try to find out which one is simplest. Let's try to find out. See, I can say this C double bond O, then it's attached with H. How many bonds this carbon can make? Sir, it can make 4 bonds. 1, 2, 3. One bond it can make with hydrogen. What can be the name of this compound? Let me tell you. In the end, we write down Al. In the end, we write down Al. Right? We write down Al in the end. So how many carbons are there? One carbon. One carbon means methane. METHANE. Replace E with Al. So methanol, or it's also called as formaldehyde. Right? Formaldehyde, or we call it as methanol. In the same way, guys, if I again take this general representation, C double bond O, single bond H. Now here I will write down CH3. Just name the compound. Again, it's 2 carbon. 2 carbon means ethane, ETHANE. Replace E with Al, so it will be ethanol. I hope this idea is clear. Now we have one more, that is functional group, that's ketone group. In ketone group, let me tell you, carbon is bonded with oxygen. Since carbon makes how many bonds? 4. So from this side carbon will make 1 bond, from this side carbon will make 1 bond. But let me tell you guys, carbon will make 1 bond from this side, there should be carbon. And carbon will make 1 bond with the carbon, there should be carbon. That is the criteria for the ketone group. You can't place hydrogen or hydrogen here. That I will tell you why you can't place hydrogen, that I will tell you in some time. But remember, you have to put carbon and carbon here. For example, if I will write down C double bond O, here I will put CH3, here I will put CH3, my dear students, right? So CH3 is there, CH3 is there. Carbon is double bonded with oxygen. I hope this idea is clear. Now if you have to name this compound, let me tell you, while naming these compounds, at the end we have to use ONE. Now tell me how many carbons are there? 1, 2, 3. 3 carbon means methane, ethane, propane, right? Can I say 3 carbon means propane? PROPANE. In place of E, write down ONE. So the name of the compound will be propanol. Similarly, guys, if I put C double bond O here, and here I will write down C2H5, right? Here I will write down CH3, for example. You have to name this compound. How many total carbons are there? 2, 3, 4. 4 carbon means butane. I can say butane. Now replace E with ONE. So the name of the compound will be butanol. I hope this idea is super duper clear. Right, guys? Now there is a question. Does ethanol exist? Let's try to make the structure of ethanol first. What do you mean by ethanol? 2 carbons. First ONE group means CO is there, C double bond O, right? Then one more carbon is there. Let us say, for example, this is carbon CH3, right? And there will be hydrogen, right? Now name this compound. Guys, few minutes back we did this. It will become that type of functional group, CHO. CHO functional group. That means it is an aldehyde. It is an aldehyde. And if you have to name it, how many carbons are there? 2 carbon. So 2 carbon means ethane, ETHANE. Remove E with Al, so it is ethanol. We are trying to make ethanol, but we got ethanol, right? We got ethanol. Even if we put H here, CH3 here, it's one and the same thing. I hope the idea is super duper clear, guys. Yes. I hope this idea is clear at the same time, right? So does ethanol exist? No. We tried to make ethanol, but we got ethanol. That's why the simplest ketone is propanol, right? This is the simplest ketone. Now last one, guys, we have carboxylic acid group, which contains a carbonyl group C double bond O, and it contains a hydroxyl group in this way, right? So carbon is making 4 bonds, 1, 2, 3, 1 bond carbon will make from this side. Imagine carbon makes this bond with the hydrogen, and you have to name the compound. Guys, how many carbons are there? 1 carbon is there. 1 carbon means methane, METHANE. Now here you have to replace E with oic acid, OIC acid. This is carboxylic acid. So you have to remove it with oic acid. So methanoic, methanoic acid. Then there's the simplest functional group. Sorry, simplest carboxylic acid. In the same way, guys, for example, again I will write down C double bond O, single bond OH. If I will put CH3 here, imagine I put CH3 here, right? You have to name it. So how many carbons are there? 2. 2 carbon means ethane, ETHANE. So in place of E, I will be using OIC, oic acid. So it will be ethanoic acid. Done. So these are the functional groups, right? So here COH group is attached. We generally say it's a COH group, right? Is attached. Then let's try to do some questions now. Guys, can you identify the functional group here? It is CHO group. So can I say that it's aldehyde? You have to identify it. CO. CO is carbonyl group. Here carbon is attached. So it's CO group or ketone group. So it's ketone. In the same, if I talk about this one, OH, alcohol or hydroxyl group. If I talk about this one, COH, carboxylic acid. Right? Done. Now we have one small topic, that is homologous series. Homologous series is actually the series of compounds or class of compounds having same functional group. We can say having same functional group and they differ by CH2 or 12 AMU, right? Sorry, 14 AMU, right? Or they differ by 14 AMU. What does it mean? Let's try to find out. What does it mean? For example, if I talk about alcohol series, guys, this is alcohol series. So I told you which one is the first. It's methanol, ethanol, propanol, butanol, pentanol, right? They're the same functional group, right? Write down the formula. Can I say it's CH3OH? Can I say it's C2H5OH? Can I say it is C3H7OH? Can I say it is C4H9OH? Can I say it is C5H11OH? Right? Clear? If I try to find the difference, any two, for example, I try to find the difference between these two. Can I do it? It's C2H5OH. Difference CH3OH. If I try to do the difference, OH cancel. H5 minus H3 will be H2. C2 minus C will be CH2. So what is the difference? CH2. Try to calculate the molecular mass of CH2. Carbon will be 12. Hydrogen will be 2 times hydrogen 1. 12 plus 2 is 14 AMU. So there is a difference of 14 AMU. Right? Atomic mass unit. If you try to do these two, for example, OH cancel. C4 minus C3 is C. H9 minus H7 is H2. So there is a difference of CH2. Right? This is called as homologous alcohol series. Similarly, we can have homologous carboxylic acid series. We can have homologous ketone series. Right? That way we can do the for all. Similarly, we can have homologous series of alkanes. Methane, ethane, propane, butane. Even guys, if I talk about methane, what's methane? CH4. What's ethane? C2H6. Try to find the difference between two. C2 minus C is C. H6 minus H4 is CH2. Right? This can be called as homologous series of, yes, alkanes. Similarly, alkenes we have, alkanes we have. Now guys, there are few of the compounds that you have to name. Right? It's related to nomenclature. You have to name few of the compounds. How actually you'll be naming? See, the first compound is very simple. It is CH3, then CH. This CH is bonded with CH3 this way, right? Clear? Right, guys? And there is CH2, there is CH2, there is CH3, right? You have to name this compound. Can you name it? Quite simple. Just identify the long chain. It will be 1, 2, 3, 4, 5. At position number 2, there is methyl group attached. Can I say it will be 2-methyl? And how many are in the main chain? 5 2-methyl pentane. You can name it this way, right? In the same way, guys, this particular compound, so it is CH3 single bond CH and it's bonded with CH3 in the bracket and it's bonded with CH3. You have to name it. Can I say 1 2 3? So 2-methyl, how many are in the main chain? Propane. So 2-methyl propane. If you have to name this compound, can you name it? Right? Can you name it? We can name it, guys. Try to find out. See, it is this way: CH3 single bond, yes, single bond. It will be CH2, I guess, right? CH2. Then it will be C H and it's CH3. Then it will be CH. It will be CH3. Then it will be CH2 single bond CH2. Then CH3, right? These are 2 2, guys, right? 2 2 and this one is also 2, right? Okay. Now we have to name this compound. How exactly are we naming this compound? Just number it. 1 2 3 4. See, 1 2 3 4 5 6 and 7. If I name this way, 1 2 3 4 5. So that way is not feasible. So this one is good. So can I say at position number 3 there is methyl group? Also at position number 4 there is methyl group. So 3 comma 4 dimethyl. 3 comma 4 dimethyl. How many are in the main chain? 7. Heptane. I hope this thing is clear. 3 comma 4 dimethyl heptane. In the same way, guys, you have to name this compound. See, CH3, then there is CH, and with this CH Br is attached. Then there is CH, with this Cl is attached, and then there is CH. See, among bromine and chlorine, we have to use the alphabetical order. Does B comes first or Cl? We'll say so B is coming first. So now just do the numbering: 1 2 3 4. So name will be 2 bromo, 3 chloro. How many are in the main chain? 1 2 3 4. 4 means butane. So 2 bromo, or we can say 3 chloro, 2 bromo, 3 chloro butane, right? That way you can name it. I hope this thing is clear. You can name these compounds now. Now these are few of the compounds that you can name. Take a screenshot of it and you can name these compounds, right? Now guys, again we have one important topic, and that is esters, right? Basically esters are organic compounds, right? Esters are organic compounds formed when a carboxylic acid reacts with an alcohol. Guys, for example, if I talk about carboxylic acids, if you remember few minutes back I told you the carboxylic acids, they contain COOH, right? And this COH is attached with CH3, for example, C2H5, that I name as methyl, ethyl, propyl, butyl, pentyl, hexyl. I'll be representing that with R, right? So that will be the general representation of carboxylic acid, right? So these carboxylic acids are COOH. They react with alcohol. Few minutes back, I told you alcohol, they contain OH. And again guys, this OH is connected with, this OH is bonded with, again methyl, ethyl, propyl, butyl that I told you, and that I'll be representing with R again. But in order to differentiate these two R's, this one I'll be representing with R dash. So now there will be the reaction R dash OH, right? Can I say that this is carboxylic acid? Can I say this is alcohol? There will occur a reaction between these two. Let me tell you, this R dash will displace this R, right? This R dash will displace this R. What will be the product that I'll be getting now? Try to find out. I will get R COO. In place of H, I will get R dash plus H2O. Look here, guys. OH plus H will give H2O. Now, this particular compound is what I call as ester. What I will be calling as ester. I hope this is clear. And let me tell you, esters contain COO group, right? Esters contain COO group. This type of group esters contain. Wherever you will find CO, you can directly say that it is an ester. So esters are the compounds that are formed when there occurs a reaction between carboxylic acid and when there occurs a relation between alcohol. What we will actually be getting? We'll be actually getting esters. Let's try to name some of the esters. Before that guys, you need to understand, while naming esters, we have R dash, right? R is from acid part and this R dash is from alcohol. While naming, we have to mention R dash first, right? While naming, we have to mention R dash first, then we have to mention R. Try to find out. For example, if I take any carboxylic acid, let's take CH3COOH. Right? What's the name of this compound? Yes, guys. 2 carbons are there. Ethanoic acid, right? Ethanoic acid. That I can write down CH3, C double bond O, single bond OH. This way we can write down. Yes, ethanoic acid. I'll be doing its reaction with, for example, ethanol. Okay, what's ethanol? C2H5OH, right? What will be the product? Tell me, guys. You can easily do it. No need to think more. I will write down the first part as such, up to CO, CH3, CO, right as such. This H will get replaced by C2H5. Why? I told you this part is R dash and this part is R, right? This part says 3, this part is R actually, and this part is R dash, right? Now this R dash, clear, guys? If I talk about this R dash, right? This R dash will displace R. So write down R dash here. What's R dash? C2H5 and water is out. Now you have to name this compound, guys. How simple this is. How simple this is. How exactly be naming this compound? I told you. This part is R. This part is R dash. So name R dash first. What is C2H5? What is C2H5? It is actually ethane. From ethane there is lack of one hydrogen, right? This I'll be calling as ethyl. ETHYL. Now name this part. How many carbons are there? 2 carbons. So ethyl eth. ETH eth. Ethane actually ETHAN. Now there is E in place of E. Remember, guys, in place of E we are using OATE. That's very important point that you need to understand in case of esters, right? Which contains COO, right? Look here, it contains COO, so it's an ester basically, right? So it's an ester. So you have to replace E with OATE. So its name will be ethyl ethanoate. I hope this idea is clear. So now if I take few more examples, guys, few more examples. For example, I will take, for example, CH3, CH2, COOH. Imagine this type of compound I will take. I will react this compound with C5H10. One second. C5. Okay. H11OH. What will be the compound that I will be getting? Look here, guys. This part I will write down as such CH3, CH2, CO. Now this H will be replaced by C5H11. Yes, C5H11 and OH water will be formed, right? Now I have to name this compound. In order to name this compound, I told you guys this part is R, this part is R dash. Just name R dash first. What's R dash? C5H11. It's pentane actually. So from pentane we'll get pentyl, PENTYL, pentyl. And now how many carbons are from this side? 1, 2, 3. 3 carbon means methane, ethane, propane. So I can say it's propane. PROPANE. Now replace E because it contains CO. CO means ester. So I have to use OATE. So it will be pentyl propanoate, right? Pentyl propanoate. I hope this idea is clear, right? Now can you name this compound quickly, guys? Can you name this? See. First of all, name this. What is this? This is methyl. What's the name of this compound? This is 2 carbon ethane. So ETHAN. E. OAT. Replace E by OAT. Why? Because there is COO. Look here, guys. There is COO. Clear? In the same way, guys. Look here. There is COO. Right? It's again ester. Now, how many carbons are from this side? 2. 2 carbon means ethyl. And how many carbons are from this side? 1, 2, 3, 4. 4 carbon means butane. BUTANE. Now replace E by OATE. Ethyl butanoate. Right? Ethyl butanoate. Right? Can you name this compound, guys? Look here. How many carbons are from this side? 1, 2, 3, 4. 4 carbon means butyl. And how many carbons are from this side? 2 carbon. 2 carbon means ethane. ETHANE. Replace E with OATE. Butyl ethanoate. Right? This compound, guys, how many carbons are from this side? 2 carbons. So 2 carbon means ETHYL, ethyl, right? ETHYL, ethyl. How many carbons are from this side? 1, 2, 3. 3 carbon means, Shabazz guys, 3 carbon means propane. So propanoate, ethyl propanoate. I hope this is clear. I hope this is clear. Let's now try to find out. There is one more, guys. This one. So there is one carbon. One carbon means ethyl, and there is also one carbon. So ethyl ethanoate, right? Done. Done, guys. Done, guys. Done, guys. Now there is one small topic that I will not discuss. Very simple thing is this. Basically, when it comes to coal and petroleum, the coal and petroleum is formed millions of years ago, right? When the plants, animals, they got buried deep inside the earth. And let me tell you, the plants we call as zooplanktons, and animals we call as, the plants we call as phytoplanktons, and the animals we call as zooplankton. So when these zooplanktons and phytoplanktons, they got buried deep inside the earth. Now deep inside the earth, there is high pressure. Deep inside the earth, there is high temperature. So because of high pressure, because of high temperature, they got converted into fossil fuels, right? They got converted into fossil fuels. Later on, those fossil fuels got converted into coal, petroleum like products. I hope this is clear. I hope this is clear. Let me tell you, this coal and petroleum, they are called as fossil fuels. Why? Because they are made up of essential fossils that are buried deep inside the earth millions of years ago. I hope this thing is clear. Clear, guys. No. One simple question. Why do substances burn with flame or without flame? Try to understand. Imagine, guys, this is one candle I am having, right? This is one candle I am having. And this candle is burning with a flame, right? Let me tell you, the fuel of candle is wax, right? Fuel of candle is wax. And this wax contains carbon. This wax contains hydrogen. Whenever we are doing burning of wax or burning of candle, we are actually reacting it with oxygen, right? And whenever we are reacting it with oxygen, can I say that this carbon part will form CO2? Can I say that this hydrogen part will form H2O? But this H2O will be in gaseous form. Guys, let me tell you, this H2O is volatile, and because of this H2O, candle has a flame. Candle has a flame. Candle has a flame, right? If you burn the piece of paper, again piece of paper will produce H2O in the vapor form, and again there will be flame. So flame is getting produced whenever there are volatile substances present in the burning substance, right? If there are no volatile substances, then there will not occur a flame, right? There will be glow, for example. In case of for example, when you burn charcoal or when you burn coal, they only show glow. That's why when it comes to charcoal, when it comes to coal, we never say burning of charcoal. We actually say smoldering of charcoal. Remember, guys, we say smoldering of coal. Don't use burning of coal. Burning will be using when there is flame type of combustion. When there is that type of combustion that produces flame, we call that as burning, right? We call that as burning. If there is flameless form of combustion, for example, in case of charcoal, for example, in case of coal, they only glow. So that's flameless form of combustion. So that flameless form of combustion will be calling as smoldering. I hope this idea is clear. Then, now this types of flame, two types of flame. One is blue flame. Let me tell you, this blue flame is non-luminous flame. And this blue flame is produced as a result of complete combustion, right? It's produced as a result of complete combustion. And when it comes to yellow flame, it is a luminous flame, right? Luminous flame. And here we have what? Incomplete combustion. I hope this idea is clear at the same time, right? Now guys, we have chemical properties of carbon compounds. One is combustion reaction, second one is substitution reaction, and third one will be addition reaction. This combustion reaction is shown by all types of hydrocarbons, be it saturated hydrocarbons, be it unsaturated hydrocarbons, right? Be it saturated hydrocarbons, be it unsaturated hydrocarbons. But generally substitution reaction, it is shown by saturated hydrocarbons, right? Substitution reaction. And addition reactions, they are generally shown by unsaturated hydrocarbons. Addition reaction, right? But it's not true that always addition reactions are shown by unsaturated hydrocarbons, right? It's not always true. That's why I'm saying generally. Look here, while it's true that unsaturated hydrocarbons are more known for their addition reactions, it's not accurate to say they absolutely do not undergo substitution reaction. So they might undergo substitution reaction as well. I hope things are clear, guys. I hope things are quite clear. I hope things are quite clear. No. Before I will move ahead, guys, I'll be discussing something about oxidation reaction. Oxidation reaction simply means whenever there is addition of oxygen, right? Whenever there is addition of oxygen. Suppose there is any compound, I have to do its oxidation, I have to add oxygen. So what I'll be doing, I'll be adding the oxidizing agent. I'll be using the oxidizing agent. Because oxidizing agent is something which can provide oxygen to that particular compound. For example, guys, I have CH3, CH2OH. What is this? This is ethanol, right? Ethanol. I want to do its oxidation. So what I'll be using, look here, it's written here, alkaline KMNO4. I'll be using alkaline KMNO4 and I'll be supplying heat. So this alkaline KMNO4 is called as oxidizing agent. Why? Because it will be supplying oxygen, and when it will supply oxygen, we will get CH3, CH3, yes, COOH, right? So ethanol got converted into ethanoic acid, right? Ethanoic acid. Then you can use one more oxidizing agent here in place of KMNO4, and that is acidified K2Cr2O7, right? Acidified K2Cr2O7. Acidified K2Cr2O7 means, for example, HCl plus K2Cr2O7. If it is written HCl plus K2Cr2O7, it's one and the same thing. If it is written acidified K2Cr2O7, it's one and the same thing, because here I am adding acid. This K2Cr2O7 is called as potassium dichromate. It's called as potassium dichromate. So it can be done with the help of this as well, right? So ethanol can be converted into ethanoic acid with the help of oxidizing agent, and that oxidizing agent can be acidified K2Cr2O7, or that can be alkaline KMNO4, right? Now guys, combustion reaction. Let me tell you, carbon compounds, they show combustion reaction, right? They undergo combustion reaction. Combustion reaction means they react with oxygen to produce. Combustion reaction is the type of reaction in which the compound reacts with or burns in presence of oxygen. Compound burns in presence of oxygen to produce products along with heat and light energy. So in short, if I talk about combustion reaction of carbon compounds, so these compounds, they actually burn in presence of oxygen to produce products along with heat and light energy. For example, let's take one simple example, guys. One simple example of methane, right? Let's take the example of methane. For example, I have CH4, right? I will burn it in presence of oxygen. So what are the products? CO2. What will be the product? H2O, and there will be light energy plus heat energy. In the same way, if I take, for example, C2H5OH, if I take ethanol, I will react it with oxygen. Clear? Again, I will get CO2 plus H2O. Along with CO2 H2O, I will get light energy plus heat energy. And I told you, all types of hydrocarbons, they undergo this particular type of reaction, which is called as combustion reaction. Now let's switch on to few more concepts. Now we have addition reaction of carbon compounds. How exactly I'll be defining this addition reaction of carbon compounds, guys, right? So in an addition reaction, a substance is added to a hydrocarbon and you actually get a single product. One best example is catalytic hydrogenation, right? In this, we'll be taking one simple example, and that will be catalytic hydrogenation, right? Catalytic hydrogenation. In this catalytic hydrogenation, guys, let me tell you what we'll be doing. Yes, what we'll be doing? we'll be taking an unsaturated compound, right? We'll be taking one unsaturated compound, C double bond C, and this C will be attached with the long chain of hydrocarbon. So I will put one R here, I will put one R here. These R's, they represent that it's a long chain of hydrocarbon. And here I'll put one R and here I will put one R. Right? This particular compound I'll be calling as vegetable oil. Right? I'll be calling this as vegetable oil. I will add hydrogen to it. I will add hydrogen to it, H2, in presence of nickel catalyst. In presence of nickel catalyst. Let's for that you need to understand what is a catalyst. Clear? I will let you know after some time. But now look here, there is the vegetable oil and I will do its addition with hydrogen and it will lead to the formation of saturated hydrocarbon, C single bond C. And there are two R's, right? From this side one R is there, one R is there. From this side one R is there, from this side one R is there. And there will be hydrogen, there will be hydrogen. This particular compound I'll be calling as vegetable ghee, or we sometimes call it as butter as well, right? And this particular reaction, this is actually called as hydrogenation reaction, right? This is called as hydrogenation reaction or catalytic hydrogenation. Now here I am using catalyst. What's the catalyst? Nickel catalyst. Catalyst is something which increases the rate of reaction, which increases or decreases the rate of reaction, but itself does not get consumed in the reaction. But itself it will not get consumed in the reaction. I hope the idea is super clear, guys. Yes, but itself it will not get consumed in the reaction. Now let's move ahead. Let us discuss one interesting point. And what's that interesting point, guys? Look here. Saturated fats like vegetable ghee obtained by hydrogenation of oils are not good for health, right? They are available in the market under different brand names. Animal fat like butter and desi ghee are also saturated fats, means single bond containing saturated fatty acids which are said to be harmful for health. So whenever it comes to saturated, it's considered to be not good for health, right? Now guys, if I'll be taking two containers, imagine that there are two containers. This is container number one, this is container number one, and I have one more container, right? I have one more container. In this container I have kept compound A, and in this container I have kept compound B. Now how they can ask you a question in the examination? You have to identify which compound contains single bond and which compound contains double bond. Point number one. Or they can ask you identify which compound is vegetable ghee and which compound is vegetable oil. You just have to identify which compound is vegetable ghee and which compound is vegetable oil. Few minutes back I told you, when it comes to vegetable ghee, it contains single bond, and when it comes to vegetable oil, it contains double bond. Clear guys? For that we'll be using one test that's called as bromine water test. And what will happen because of bromine water test? Let me tell you guys. Very simple thing. We know that bromine is a red brown liquid, right guys? It's a red brown liquid. If I add this bromine to the compound containing double bond, right? If I add bromine to the compound, imagine in this compound I am adding bromine, right? And in this container I am adding bromine. Now the compound that contains double bond, bromine will break the double bond. So basically what will happen? If an organic compound decolorizes bromine water, then it will be an unsaturated compound. So if it decolorizes, so this one it will be decolorizes, right? Since it's red brown, when you put it in it, it will decolorize. It will get decolorized, and we can confirm that it's a double bond. And if it will not decolorize, I will say it's a single bond. I hope this idea is clear, right? So if an organic compound decolorizes bromine water, then it will be an unsaturated compound containing a double bond or a triple bond. So basically you will be adding, if you take one more container separately, right, in that separately container you keep bromine water and you'll be adding some drops of this compound into this. If it decolorize, then you can say it's double bond. If it does not decolorize, you will say it's single bond. Done? So how can we distinguish chemically between cooking oil and butter? So bromine water decolorizes when cooked in oil, indicating that it's an unsaturated compound. So unsaturated means decolorizes. Right? Clear? That's it. Now there is one more, that is substitution reaction of carbon compounds. How this substitution reaction works actually? So a reaction in which one or more hydrogen atoms of a hydrocarbon are replaced by same atoms like chlorine, bromine, etc. Right? If you are replacing with the help of chlorine, that reaction will be calling as chlorination. Simply iodine, iodination. Similarly fluorine, fluorination. And similarly if you are adding bromine, that's called as bromination. Now how exactly I'll be doing this? For example, I have CH4, right? I have CH4. I will add this CH4 with, I will just treat it with Cl2. What will happen, guys? This chlorine will displace hydrogen and it will form CH3Cl, right? Plus HCl. If I take again this CH3Cl, I will treat it with Cl2, right? I will treat it with Cl2. So it will lead to the formation of CH2, right? Cl2 plus HCl, right? Again, if I take CH2, Cl2, I will treat it with Cl2. What will happen? Guys, it will lead to the formation of CHCl. Look here, CH, one hydrogen will get replaced, CHCl3 plus HCl. Again, if I take this CHCl3, I will treat it with Cl2. It will lead to the formation of CCl4 plus HCl, right? And these reactions we call them as chlorination because we are adding chlorine. And guys, this particular compound is called as mono. This is called as, one second. This is called as chloromethane. Yes. This is called as dichloromethane. And this compound is called as trichloromethane, and this is called as tetrachloromethane, right? This is called as tetrachloromethane. In the same way, you can add Br2, right? The reaction will be bromination, right? That's it. That's how you will be doing these sorts of reactions. Now guys, we have some important carbon compounds, and the first one is ethanol, right? You should know that ethanol is actually, it belongs to the homologous alcoholic series, and it is the second member of homologous alcoholic series. Clear? And it's also known as methyl carbonyl, and we actually write it in this way, CH3 CH2OH, right? That's what I'll be calling as ethanol, right guys? Two carbons are there, OH group is there, so I'll be calling this as ethanol. Now it has few properties. It's a colorless liquid having a pleasant smell, guys, having a pleasant smell. It boils at 351 Kelvin, remember this point as well. It is miscible with water in all proportions, remember this point. It's a non-conductor of electricity, right? Remember this point. It's neutral to litmus at the same time, right? It's neutral to litmus at the same time. So these are few of the points that you need to remember while dealing with this particular topic. Now look here, related to this ethanol, we have few terms, we have few terminologies. One I'll be calling as, yes, rectified spirit. One I'll be calling as rectified spirit, right? One I'll be calling as, yes, denatured alcohol. Third one I'll be calling as absolute alcohol. These are few terminologies related to ethanol, right? Now what does these terminologies mean one by one? Let me tell you. Rectified spirit, it is ethanol plus 5% water, right? It is ethanol plus 5% water. Imagine you have one container, guys. In that container you have, for example, 95 grams of ethanol and you add 5 grams of water, right? Now this one I'll be calling as a rectified spirit, right? Similarly, we have absolute alcohol. Absolute alcohol is 100% alcohol, right? It's 100% alcohol, right? It is 100% ethanol, not alcohol, 100% ethanol. It is 100% ethanol. In the same way, we have denatured alcohol. Now look here, guys. Sometimes what we do, we add few things to ethanol. For example, I'll be adding pyridine to it. Sometimes copper sulfate to it, right? Clear guys? To make it poisonous, right? So that humans will not consume it. Clear? To make it poisonous, right? Humans will not consume it. I'll be calling this as denatured alcohol. And this denatured alcohol is not fit for human consumption. I hope this thing is clear. I hope this thing is quite clear, right? This thing is quite clear. We also add methanol to it. Now guys, what are the chemical properties of ethanol? The first chemical property of ethanol is combustion. So ethanol shows combustion. You should know it guys, ethanol shows combustion. What does it mean? If I am talking about ethanol, CH3, CH2OH, right? It shows combustion means it reacts with oxygen, right? It burns in presence of oxygen and it leads to the formation of CO2 plus H2O. And there will be light energy and there will be the formation of heat energy. So these are the products that are getting formed and these are the energies that are getting formed here. So there occurs combustion. So ethanol burns in air with a blue flame, right? Because complete combustion took place. Now second one is oxidation guys. Second one is oxidation. By mild oxidizing agent, for example CrO3. CrO3 is called as chromic anhydride. Remember guys, oxidation I told you a few minutes back, addition of oxygen. So if you add oxygen guys to ethanol, CH3CH2OH, you are adding oxygen in presence of CrO3 chromic anhydride. It will lead to the formation of CH3CHO. Can you name what is the name of CH3CHO? So there are two carbon atoms. I can say it's ETHAN. In place of E, there is CHO. CHO is aldehyde, so it is ethanol. So it is ethanol. ETHANAL, ethanol, right? So this compound is what I'll be calling as ethanol. Or you can do it by strong oxidizing agent. For example, K2Cr2O7 plus H2SO4 or plus HCl, right? Hydrochloric acid or sulfuric acid, for example, or alkaline KMNO4. Now, if you do it, if you use strong oxidizing agent, guys, right now if you use acidified, this time if you use acidified K2Cr2O7. Acidified K2Cr2O7 means H2SO4 plus K2Cr2O7. It will lead to the formation of CH3COH. And you should know what CH3COH, it is ethanoic acid. Done? Now reaction with sodium metal. Guys, again if I take CH3, CH2OH, I will react it with sodium metal. What will happen? This sodium will displace hydrogen, right? And when it will displace hydrogen, it will lead to the formation of CH3, CH2ONA, right? ONA. Clear? CH3, CH2ONA plus hydrogen gas. This is clear. Now you have to name it. What's the name of this compound? How many carbons are there? 2 carbons are there. So, and there is sodium as well. So I'll write down sodium first. Sodium. How many carbons are there? 2 carbons. 2 carbon means F. And there is oxygen as well. In place of oxygen, I'll use oxide. So this will be sodium ethoxide. So the name of this particular compound is sodium ethoxide. I hope this is clear. So when you treat this ethanol with sodium metal, it will lead to the formation of sodium ethoxide. In the same way, there is dehydration of ethanol. So dehydration of ethanol means, if I am talking about CH3, CH2OH, right? The dehydration means loss of water. Now, how you will be doing it? You will treat it in presence of, right? You will heat it in presence of, concentrated sulfuric acid, right? Concentrated sulfuric acid. And the temperature will be keeping is 170 degrees Celsius, right? The temperature will be keeping is 170 degrees Celsius. Now there is the loss of water. Look here guys, if I make this structure, I can say carbon, single bond carbon, there is hydrogen, hydrogen, there is hydrogen, hydrogen, and there is OH. So loss of water means this. Loss of water means this, right? Now done understood. How many bonds carbon can make? 1 bond, 2 bond, 3 bond, right? That way carbon is making 4 bonds. You have to make the 4 bonds, right? So you have to put hydrogen here. In the same way, carbon makes how many bonds? 1 bond, 2 bonds. So how you have to pick? You have to keep 4 bonds here. Now, how exactly you will be making 4 bonds now? How exactly you will be making 4 bonds here? So basically what I'll be doing, I'll put a double bond here, right? I'll put a double bond between carbon and carbon. So it will lead to the formation of, guys, CH2 double bond CH2. Now this CH2 is what we call as ethane, right? It will get dehydrated, means water will come out. I hope this is clear, right? I hope this thing is clear. Right? So water will come out. When water will come out, guys, look here, it's C. It was C, single bond C initially. There is 1, 2, 3 hydrogen. Now there is only 1 hydrogen because now that hydrogen is gone, that OH is gone. Now this bond I will put here, right? And I'll make a double bond here. Now see, Carbon 4 bonds, 1 2 3 4, 1 2 3 4. Clear? And guys, let me tell you one important point. This concentrated H2SO4 is what I'll be calling as dehydrating agent. This is called as dehydrating agent because it helps us in dehydration of ethanol. Done? Now reaction with carboxylic acid that we already did. So carboxylic acid plus alcohol, it leads to formation of acetate plus water, right? For example, if I talk about ethanol now, right? For example, the ethanol is CH3 CH2OH. Ethanol, I will do its reaction with carboxylic acid. So if I take any carboxylic acid, for example CH3 COOH, what will happen? It will lead to the formation of ester. So ester will be CH3 COO CH3 CH2, and there will be the formation of H2O, right? This CH3CO will remain as such. In place of H, I will use CH3 CH2 plus H2O. Now we can name it. How many carbons are there from this side? 2 carbons. So it will be ethyl, right? How many carbons are from this side? 2. Ethyl ethanoate, right? Ethyl ethanoate. That I showed you few minutes back, right? No need to do it. Now guys, let's move on. Now uses of ethanol. So ethanol, it can be used as a solvent in paints. At the same time, it's used in alcoholic drinks. It's used as a fuel for vehicles, and it's used in making ethanoic acid, right? That I showed you a few minutes back, how you can convert it into ethanoic acid. Done. Now look here, harmful effects of drinking alcohol. Look here. He drank the alcohol and now he is sleeping somewhere on the road, right? As such. So we know that, guys, alcohol, it affects our central nervous system. Right? It affects the central nervous system. At the same time, it can affect the liver, right? So it can affect our central nervous system. It can affect our liver. That's why this is like drinking much alcohol is not good for human health, and a person should avoid drinking alcohol. It's not a good habit at all, right? So these few points you can write in your examination. Now we have one more, that is ethanoic acid. What is ethanoic acid? You should know. The first thing is it is CH3 COOH, ethanoic acid, and again it is the second member of homologous. It is the second member of homologous carboxylic acid series, right? Carboxylic acid series, right? That's ethanoic acid. Its boiling point and melting point, I'll let you know, guys. Its boiling point is 118 degrees Celsius, right? Its boiling point is 118 degrees Celsius, and its melting point is 290 Kelvin, right? Its melting point, guys, is 290 Kelvin. Now look here, one interesting point that I will let you know from here. This ethanoic acid, its melting point is 390 Kelvin, which is approximately equal to 17 degrees Celsius, right? Or 18 degrees Celsius, right? Approximately it's equal to 17 degrees Celsius, right? 290 Kelvin or 17 degrees Celsius. We have the formula. Temperature on Kelvin equal to degrees Celsius plus 273.15. Now you can do the conversion. Kelvin, you know, 290 minus 273.15 will get approximately 17 degrees Celsius, right? Now look here. 17 degrees Celsius is the melting point. It's a melting point, right? It's a melting point of it, which is 17 degrees Celsius. So that is why during winter, this ethanoic acid freezes easily, right? It freezes easily during winter. So we sometimes call it as glacial acetic acid. Glacial acetic acid, right? Acetic acid, right? Glacial acetic acid. Why we call it as glacial acetic acid? Because during winter it can freeze, right? It can freeze during winters easily, right? That's why we call it as glacial acetic acid, as its melting point is 17 degrees Celsius. So what will be its freezing point? It will be below 17 degrees Celsius, right? Done, understood, guys? No, look here, this ethanoic acid has many names. So kids will be calling it as vinegar. For example, you went to this person, went to this uncle, and you will say, Bhaiya, vinegar दिलाइएगा अच्छे से. Legends will say, Bhaiya, acetic acid दिलाइएगा अच्छे से. And Pandu. You know who is Pandu? Yeah, let me know who is Pandu. Pandu will say, Bhaiya, CH3COH दिलाइएगा अच्छे से, right? So either we call it as vinegar, acetic acid, and CH3COOH. And this CH3COOH is what I'll be calling as ethanoic acid, right? Ethanoic acid. Done and dusted. Let's now move ahead. There are some interesting facts, guys. You should know it. So a dilute solution of ethanoic acid in water is called a vinegar. Done. Vinegar contains about 5 to 8% of ethanoic acid. Done. Vinegar is widely used for preserving pickles, right? These are few interesting points that you should remember. Now guys, let's switch on to chemical properties. The first chemical properties is halogenation. If I talk about, I have CH3COOH. Halogenation means I will do its reaction with, for example, chlorine. What will be the product if I do its reaction with chlorine? It will lead to the formation of, yes guys, can you let me know? See, this CH will remain as such, but this chlorine will displace this hydrogen here. This chlorine will displace this hydrogen here, right? This chlorine will displace this hydrogen. So it will lead to the formation of CH2, yes guys, CH2, Cl, CH2, right? Then Cl, right? COOH, right? CH2, yes, Cl, CO. Done. Now take the CH2, Cl, COH. Again treat it as chlorine. It will lead to the formation of CH, Cl2, COH. Again if you take this CH, Cl2, COH, you will treat it with Cl2. It will lead to the formation of CCl3, COH. I guess I am right? Right? Done guys. I hope that is clear. I'm very much thaka hua, right? Okay guys, look here. This is called as monochloroacetic acid. Monochloroacetic acid. This is called as dichloroacetic acid. This is called as trichloroacetic acid, right? So this is halogenation. Next one will be reaction with alkalis. We know that guys, when we treat acid, for example, we have CH3COH. This will act as acid. If I do its reaction with alkali, for example, base NaOH, right? So acid plus base, it will lead to the formation of salt plus water, right? It will lead to the formation of salt plus water. So here, if I treat CH3COH with NaOH, it will lead to the formation of CH3COONA plus H2O. Now this is called as sodium, yes, ethanoate. C-double-bond-O is there, so it's called as sodium ethanoate. Two carbons are there, so ethanoate. Clear guys? So this is called as sodium ethanoate and water will be the product there. Let's move on. Now reaction with carbonates guys. Ethanoic acid reacts with sodium carbonate to produce sodium ethanoate with byproduct and water. So for example, if I again take CH3COOH, I will do its reaction with sodium carbonate. What sodium carbonate? Na2CO3. So it will lead to the formation of CH3COONA again, right guys? CH3COONA plus H2CO3, right? CH3COONA plus it will lead to the formation of CO2 plus H2O. So there will be the formation of CO2 as well, right? It will be the formation of CO2 as well. CH3CONA, right? CH3CONA, and there will be CO2, there will be H2O. Clear? In the same way, bicarbonates guys. If I do its reaction with bicarbonates, again the products will be CO2, again the product will be water, right? Again the product will be sodium ethanoate. Like here, the product is sodium ethanoate. I hope this is clear. Now all the properties are clear. Now you can do one simple question guys. You can do one simple question now. The simple question is, the product obtained upon reaction between K2CO3 plus CH3COOH. This is metal carbonate. Yes, but this time it's potassium carbonate and this is acid. What will be the product? Guys, I told you, products will be CO2, product will be water, and product will be, like in the previous case it was sodium ethanoate, now here it's potassium ethanoate. So D, C will be the right answer. CH3COK, CO2, H2O. Done? Done, guys. How ester formation took place, guys? Ethanoic acid reacts with an alcohol in the presence of slight amount of concentrated sulfuric acid to form ester. That we did already. There is one more reaction, that is decarboxylation. That's removes carboxylic group, right? Removes carboxylic group. What does it mean, guys? Basically, we treat ethanoic acid, CH3COH. We treat it with soda lime. It leads to the formation of methane and it leads to the formation of carbon dioxide. What is soda lime? What's soda lime? Soda lime is a mixture of NaOH and it's a mixture of CaO. NaOH plus CaO. It's a mixture of NaOH plus CO. How many parts of NaOH, guys? 3 parts of NaOH. And how many parts of CaO? 1 part of CO. So it loses CO2 and forms an alkane, that is CH4 methane over there. So reaction is written over there, right? Now, guys, what are the uses of esters? Can you let me know what are the different uses of esters, Shabash? What are different uses of esters? Yes. So fruity smelling compounds. Esters are called as fruity smelling compounds, right? They are called as fruity smelling compounds. So they are used in perfumes, right? That's their use. They are used in perfumes. Done, guys. Already done. And now let's move on to the last part, and that last part is detergents and soaps. For that, we need to understand one important reaction, that is saponification reaction. How exactly I'll be doing saponification reaction? Guys, I will take an ester and I will do the reaction of ester with base. The base can be NaOH, or the base here I can treat as KOH. When I do this reaction, it will lead to the formation of soap and it will lead to the formation of glycerol, okay, or alcohol. So how exactly? Take the general ester, guys. Take general ester. We know that the general ester is R, COO, R dash, right? When I do its reaction with NaOH, for example, or KOH, this Na will displace R dash, right? So it will lead to the formation of RCOONA plus R dash OH. Let me tell you, this RCONA is what I call as soap. This R dash OH is what I call as glycerol or alcohol. I hope this is clear. Now, if you take a long chain, for example, you will get a soap. For example, if in place of R, you will mention that group. In place of R dash, you will mention the group. You will actually get the soap, right? You will get the particular type of soap, right? Done, guys. Now, what is soap? I can define soap as soap is defined as the sodium salt or potassium salt of long chain carboxylic acid, right? Clear, guys? So soap is defined as the sodium salt or potassium salt of long chain carboxylic acid. In the previous case, guys, I told you how you get the soap. You do the reaction of ester with base, and you should know that this ester is acidic in nature, right? And if this is base, so acid plus base, it will lead to the formation of salt. That's why these soaps are actually basic in nature, right? They are actually basic in nature. I hope this is clear. Yes, is the idea clear? Done, guys. Yes. Okay. Now there is question, why is common salt sodium chloride added while soap making? Yes, common salt is added to separate the soap from the mixture. Salt reduces the solubility of a soap in water, so the soap precipitates, comes out and can be collected easily. Done. While you do the saponification reaction, right? Why you add NaCl? Because NaCl helps to separate the soap from the mixture, right? It helps to separate the soap from the mixture. That's it. That's the simple answer of the question. Because soap reduces the solubility of soap in water, right? And a soap can form the precipitate and all that. That's why. That's the reason. Now cleansing action of soap, how soaps actually work. For that, we need to understand the structure of soap molecule, right? We need to understand the structure of soap molecule. Let me tell you guys, if I talk about soap, soap has two parts. How many parts? Soap molecule has two parts. One is tail, second one is head. Let me tell you guys, head is hydrophilic in nature, and tail is hydrophobic in nature. If I talk about this particular head, guys, this head contains, generally when I talk about soaps, right? When I talk about soaps, for example, if I talk about any soap, this head contains COO negative Na positive part, or it can be COO negative K positive, right? And this tail will be hydrocarbon part, long chain of hydrocarbon, right? Why this head is called as hydrophilic? Hydrophilic means water loving. Okay, hydrophilic means water loving. You will get the idea in some time. Why I'll be calling this as water loving. Basically, guys, if I take one container, imagine this is one container I am having, right? In this container, I have kept something that's dirty, right? That contains dirt. That dirt I'll be representing this way, right? This is, for example, dirt, or I'll represent it in this way, in the easy way. This is, for example, the dirt molecule. We call this as dirt, oil, or grease, right? When I put soap in it, so I know that few minutes back I told you, this is the soap molecule, guys. This way, this is the soap molecule. It has head and it has tail, guys, right? This way. Now tell me, when there will be the soap molecule, so what will happen? This head will go into water, guys. Simple. Head will go with the water because head is hydrophilic. Water is also, why hydrophilic means water loving, and this tail will get attached with the dirt this way, right? In the same way, other soap molecules will do the same thing. Other soap molecules will do the same thing. Other soap molecules will do the same thing, guys. Right? Other soap molecules will do the same thing. And this cluster of molecules is what I'll be calling as micelle, right? Micelle, right, guys? This cluster of molecules is what I call as micelle, right? This is called as micelle, and this particular process is called as micelle formation. And after we do agitation, agitation means we hit it. For example, in case of cloths, we do agitation, right? We hit the cloths, right? And then this dirt will come out from the cloth, right? That way actually soap works. That way actually soap does the cleansing action. So how soap does the cleansing action? Soap does the cleansing action with the help of micelle formation, right? So soap makes the micelle. Let's now move ahead, guys. Now we have detergents. What are detergents, guys? Detergents are generally ammonium or sulfonate salts of long chain carboxylic acids. In detergent, what we have this type of benzene ring, guys. Let me tell you, in detergents we have this type of benzene ring, right? We have this type of benzene ring, right? And one part of the benzene ring is attached with, for example, sulfonate group, which is SO3 negative Na positive, and one side is attached with the long chain of carbon, for example C12H25, right? This is one detergent, for example, right, guys? This is called as sodium P. There are 12 carbons. 12 carbon means dodecyl, right? 12 carbon means dodecyl, right? 12 carbons. And there is sodium also. So sodium, let me name it. This is one detergent. Let me name it sodium dodecyl, and there is benzene as well, benzene sulfonate. That's the name of the detergent, right? If you remember it, well and good, right? So this is benzene ring, and one side is attached with SO3 negative Na positive. Opposite to that side, there is attached C12H25. Since look here, they are in the opposite positions, they are at the para positions, so we also call this sodium P dodecyl benzene sulfonate. That's written over there. Sodium P dodecyl benzene sulfonate. Right, guys? So these are the detergents. Right, guys? Now we are at the end. Cleansing action they do same way as like soaps do the cleansing action. That way they do. Now there are some harmful effects. Some of the detergents are not biodegradable. Right? Detergents are not biodegradable. That's they cannot decompose. They cannot be decomposed by microorganisms. Right? Like bacteria, and hence cause water pollution. Right? So that's why that's one of the disadvantage. That's one of the demerit of detergents. But you should know that, guys, detergents always work good in hard water. Right? We have soft water and hard water, and in soft water soaps can work well, but in hard water detergents, what happen? Detergents work well, because in hard water if you put soap, it can form scum. It can form, soaps can form scum. Right? And that's why we use detergents. I hope this is clear, guys. Would you be able to check if water is hard by using a detergent? If the water lathers only after using a lot of detergent, water is hard. If the water lathers quickly with a small amount of detergent, water is soft. So if the water lathers only after using a lot of detergent, you will be using a lot of detergent, then you can say water is hard. But in case of soaps, if the water lathers quickly with a small amount of detergent, water is soft. That's it. And I hope this was the one shot of the class, guys. I hope you enjoyed it, and stay connected. We'll be uploading other lectures as well. Thank you.